Learn how to create a complete iOS app from scratch using SwiftUI and Xcode. In this tutorial, Carlos will teach you to build a feature-rich movie and TV browsing app with a dynamic home screen, powerful search, and detail screens that play YouTube trailers. You'll also implement a download manager to save titles for offline viewing using SwiftData. By integrating the movie database and YouTube APIs, this project provides excellent hands-on practice with SwiftUI, API integration, and modern data storage.
Hey everyone, Carlos from Blossom Build, back with a new exciting project. We'll be building a complete iOS app from scratch using SwiftUI and Xcode. Before we look at the app, I want to give a quick shout out to Amr. I originally learned how to build this app by watching Amr's YouTube channel. He built it using UIKit, and I learned a great deal from him. Please check out his channel and show some support. This is a similar app, but updated with SwiftUI, SwiftData, and the latest iOS version. There are also a few more added features. We're going to try to keep the app updated so it can remain a valuable resource. Let's take a look at it. I named it Blossom Movie. First, opening the app, you can see it has 4 tabs on the bottom toolbar. The home screen features a hero title that changes whenever the app is opened. Scrolling down, the app shows trending movies and TV shows, as well as top-rated movies and TV shows. We're able to scroll vertically to get more titles that are instantly loaded. This is possible by working with the movie database API. Clicking on a title opens the details screen. This screen contains a name, description, and a YouTube trailer. This project also works with the YouTube API. Navigating to upcoming, we see a list of upcoming movies in a vertical list this time. We can scroll down to quickly get more titles. Selecting any title brings up the title detail screen. Moving on to search, this is my favorite part of the app. The titles are on a grid this time, and we can conduct a search. For example, I can search for Harry Potter and instantly get results. We can cancel, and a default list displays. The button up top can be pressed to switch the search to TV shows. I'll search for my favorite TV show, Breaking Bad. Finally, we have the download tab. Currently, this message is displayed because we have no downloads. If we download a title and go back to the download tab, it displays right away. Closing and reopening the app does not remove it from the download tab. We can instead swipe left to delete the file. This is a great app to build for some practice with SwiftUI, APIs, SwiftData, and more. I'm excited to start this journey with you. We're ready to start this project. The first step, of course, is to create it. Before that, please make sure your Xcode and macOS are updated. I'll select Create New Project. We're going to be making an iOS application. Next, for the product name, let's go with Blossom Movie. I do have myself as a team. To do this, you'll have to log into your Apple ID. You can also use none. The organization identifier is a domain name of your company backwards. I have mine as Blossom Build, but feel free to use yours or make one up. Interface has to be SwiftUI, language Swift, testing system none, and storage none. We'll be using SwiftData as a storage. However, if we select it, the project will create unnecessary code. It's easier to add later. Hit Next. You can save this project anywhere you like. Select Create once you got your folder. We have our project created, and the famous Hello World pops up. I'll do Command-Control-F to go full screen. I'll also make my canvas smaller to allow more space for the code. I do want to write just a bit of code to get our feet wet. A good place to start is to create the 4 tabs our app will use. In the content view, we can delete from padding up to VStack. Instead, type tab view, open curly brace, and enter. Inside the tab view curly braces, we need to define our tabs. Type tab, open parentheses. There are two parameters here. First, a string for the tab name. Quote, type in home, quote again, comma. The second parameter is the icon image we want to use. We're going to be using the free SF symbols built into Xcode. Type system, and Xcode is recommending the correct name. Press tab to autocomplete. Quote, type house, close quote, close parentheses, open curly brace, and enter. Inside these braces, we need to define the content of this tab. A text displaying home would do just fine. That is our first tab complete. Notice our preview updated correctly. For efficiency, let's copy our tab by highlighting and pressing Command C. Paste it 3 times with Command V. The second tab will be called Upcoming. We can change system image to play.circle. The text will also change to Upcoming. The third tab is Search. System image will be magnifying glass. Text, of course, is also Search. Finally, we have Download. System image is arrow, .down, .to, .line. Text is also Download. I think that looks pretty good for now. We can click through the different tabs in our canvas to confirm. We build our bottom toolbar containing 4 tabs using pretty simple code. SwiftUI makes it that easy. This is a great place to stop. Awesome work. We have our tab view working properly. Before we get into more SwiftUI, a quick topic. Currently, our content view contains hard-coded strings. An example is the home string in our first tab. While hard-coded strings are convenient, they can lead to typos and be harder to maintain when the application grows. This is not going to be a published app, but I do believe in building good coding habits. Therefore, we'll create a constant file and put all the strings there. To begin, use the shortcut Command N to make a new file. Select Swift file. Next, call this file constants. Create. Under Import Foundation, type struct constants. If the editor recommends the correct syntax, press tab to complete like I just did. Time to make our first string. Static let home string equals home. Static allows this string to be accessed across the app. Let means the string won't change within the program. Of course, we can still change it in the code. We'll keep going. Static let upcoming string equals upcoming. Static let search string equals search. Static let download string equals download. It's also good to be specific when naming variables. Navigate back to content view. Delete home. Instead type constants dot home string. Do the same for the home inside text. Upcoming is next. Delete and replace both occurrences. Constants dot upcoming string. Constants dot upcoming string. Next to search. Constants dot search string. Constants dot search string. Finally, download constants dot download string constants dot download string. We also want to put the system image names in our constants file. Go back to constants, make some space, static let home icon string equals house, static let upcoming icon string equals play.circle, static let search icon string equals magnifying glass, static let download icon string equals arrow.down.to.line. Back to our content view one more time. Replace house with constants dot home icon string, play.circle with constants dot upcoming icon string, magnifying glass with constants dot search icon string, and arrow.down.to.line with constants dot download icon string. Not the most exciting work, but it's good for us in the long run. One more benefit to doing this is easier migration to different languages. We'll stop here, but I promise to have exciting SwiftUI action next time. We're effectively following good stream practices. It'll be easier to apply for the rest of our app. Now we can start working on the home screen. I do want our content view to stay clean and just hold the tab view. It'll get big fast if we code all the screens on it. Let's make a new SwiftUI file for the home screen. Press Command N, SwiftUI view, next, home view, create. The home screen first features a hero title. All the images used for this app are inside the internet as URLs. For testing, we can define a temporary image at the top of our home view. Hit enter after the first curly brace twice. Back to line 11. Var, hero test title equals quotes. Navigate to constants. After our last string, hit enter a couple times. Static let test title URL equals single quote. I'll paste a sample URL. It will be in the video description. Please copy and paste it as well. Go back to home view. Replace the empty string with constants.test title URL. Now we can build our view. Delete the text view. Type vstack with braces. Vstack aligns all the views inside its braces vertically. Our image needs to be loaded asynchronously because it's coming from online. This means it loads on a separate thread, not the main thread. That's for our UI. SwiftUI has a great tool called async image. Start typing async, select the second one, and press enter. Async image takes a URL, but our hero test title is a string. We can easily convert it by typing URL in all caps, open parentheses, string, colon, hero test title. We're using Beetlejuice as our practice title. I honestly like the poster art. The image is pretty big right now. In order to adjust it, put braces at the end of our async image. After the first brace, type image in. This puts our async image inside a variable called image. We can put modifiers on this variable to adjust it. Before we do that, we have to define a placeholder while the image loads. After the async image curly braces, type place and hit enter to autocomplete. In the placeholder braces, we can type progress view. As the image loads, progress view, which contains a progress circle, will show. Let's go back inside our async image braces. Type image.resizable.scale to fit. These two things we just added are called modifiers. Modifiers allow us to change our views. In this case, we're allowing the image to be resizable and fitting it in our parent view without distortion. Modifiers are usually in separate lines so they can stand out. Put your cursor right after the E in image and press enter. I'll press escape to dismiss that suggestion. Press enter again after the resizable closing parentheses. This is looking pretty good. I also think it's a good place to stop. Great job on this one. Our hero test title is displayed correctly. Under the hero title, we need two buttons. One button to play the trailer and another to download the title. Make some space after the placeholder braces. These two buttons should be side by side. To do this, we can type hstack with braces. Hstack orders its views horizontally. Inside our hstack, type button with braces. After the closing brace, type label and hit tab to autocomplete. In the first set of braces, we'll tell the button what action to perform. The second set is for design. Before that, we need to define a string. Navigate to constants. Make some space after the download string. Static let play string equals play. Lucky for us, the download string is already defined. Navigate back to home view. Inside label, type text constants dot play string. We can now see a small play button in our preview. Copy and paste the button code to make another one. Change the second text to constants dot download string. These buttons work, but they need some design. We can add some modifiers. After the play string text, hit enter and type dot frame. The first option isn't what we need. Press your right arrow key for more options. Select the option that contains width and height. The frame modifier adds an invisible frame with a specified size. Put 100 for the width and 50 for the height. Press enter after the closing parentheses and add dot bold. This bolds the text. A border would look nice around the button. Press enter. Dot background. We want the one that has content. Press enter for braces. Inside the background braces, input rounded rectangle. Select the option with corner radius and style. Use 20 for the radius and dot continuous for style. This makes a rounded rectangle with the radius of 20, but our text is covered. We can use the stroke modifier to just keep the border. After the closing parentheses, press enter, type dot stroke, select the one with line width 5, much better. The button looks pretty good, but I would like to add our custom color. Navigate to assets, right click, new color set, button border, enter, open the inspector, change appearances to none. This color will be the same for dark and light mode. Click where it says universal, show color panel, type in 34 B4 6C for the hex color. Enter. That's Blossom Build Green. Close the color panel. While we're here, let's add one more color. Right click, new color set, button text, enter. Make sure appearance is any dark. Click on any appearance, show color panel, 6 zeros, 1, 2, 3, 4, 5, 6, enter. Close the color panel. When the app is in light mode, the button text color should be black. In dark mode, the color should be white. This is a great place to stop. Outstanding work. The colors are ready to go. We just need to apply them to our buttons. Navigate back to Home View. In our play text, after frame, hit enter. Type dot foreground. Press enter on foreground style. Use dot button text for the argument. This modifier defines the text color. A quick reminder, button text is black for light mode and white for dark mode. We can test this by selecting Canvas Device Settings, Toggle Color Scheme, Dark Appearance. The play text changes to white. I'll toggle back to light mode for now. Let's add our border color. In the stroke modifier, before line width, add a comma. Left arrow key once. Dot, button, border. I'd say the play button looks much better. We can't leave the download button hanging. It would be easy to copy and paste the modifiers to the download button. However, this brings us to our next coding principle, the famous don't repeat yourself or dry idea. Dry is all about promoting efficiency and reducing redundancy. If we, the developers, are going to use code more than once, we should only write it once. Of course, as with any principle, try to follow it the best you can. Don't lose any sleep if you can't use it 100% of the time. This button style is used a few times in the project. Hence, let's write the code once and use it more. Notice the modifiers are on text, not the button itself. Therefore, we can create a function that automatically applies these modifiers to a text. Highlight the modifiers, copy with Command C, navigate to constants. At the top, import SwiftUI. This import is needed because we'll be calling SwiftUI elements. Make some space after the closing braces. Type extension, text, with curly braces. Extension allows us to add functionality to an already existing type without modifying the original. Inside the braces, type func, ghost, button, parentheses, return arrow, some view, with braces. This creates a function called ghost_button that returns a view. Inside the braces, type self. Self refers to the current instance where the function is located. The function is located inside an extension of text. Therefore, self refers to text. Hit enter after self and paste the modifiers. Usually, when a function returns a value, you have to type return at the end. However, because self is the only thing written and matches the return type, it automatically returns after applying the modifiers. Steer back to home view. Delete all the modifiers in our playtext. Instead, type .ghost_button. Go down to our closing download text parentheses. Enter .ghost_button. Our custom function, ghost_button, applies all the modifiers we defined. If you ever need to see the source code of a function, hold Command and click on it. Very helpful for looking under the hood. Back to home view. The code looks pretty, and most importantly, it was easy to use. This is because we took the time to make it more efficient. Go ahead and click on the buttons for a quick test. Notice the whole button clicks when tapped. Switching to dark mode, it looks awesome. This is a great place to stop and take a break. Outstanding job again. I can't wait to see you in the next one. The home screen is really coming together. We have a hero title and 2 buttons underneath. Our next step is to make the horizontal list under the buttons. There'll be 4 lists total. These lists will be trending movies, trending TV shows, top rated movies, and top rated TV shows. Keeping the dry method in mind, we'll create one file and reuse it. First thing we need is more test images. Navigate to constants. Make some space after test title URL. I'll make sure to include these strings in a description. Please copy and paste them. Static let test title URL 2 equals paste. Static let test title URL 3 equals, I'll grab the string, paste. While we're here, let's also make a trending movie string. Press enter after play string. Static let trending movie string equals trending movies. Great work. Use Command N to make a new file. SwiftUI view. Next. Horizontal. List. View. Create. Let it load. Press enter twice after the first brace. Up arrow once. Let header equals constants dot trending movie string. Var titles equals bracket constants dot test title URL, comma, constants dot test title URL 2, comma, constants dot test title URL 3. We define two variables here. Header is our trending movie string. Let was used because it won't change. Titles is an array of strings currently holding our 3 test titles. Var was used because the list might change when the data refreshes. Delete the hello world text. Instead type vstack. Down arrow to the one that has alignment and more options. Right arrow. Select the one with alignment and content. For alignment, put dot leading. Tab. Hit enter to get braces. This vstack will align all its views to the left of the phone. Inside the braces, text, header. Add the modifier .font, .title. This makes the text bigger. Under the text, type scroll view with parentheses and curly braces. Scroll view allows us to scroll through views that exceed the screen capacity. Inside the parentheses, put .horizontal. This allows our views to scroll horizontally. In the braces, type lazy hstack with braces. Lazy hstack only loads the views when needed. Inside lazy hstack, for each titles, open brace, title in, enter 3 times. For each is a handy tool that loops through a list. It also gives us access to each element. We're getting an error because each element needs to have an ID. Since each string is different, we can use the string itself as an ID. After titles, comma, ID, colon, backslash dot self. We can now access each element in our titles array. Each element is represented by the title variable after the braces. Inside for each, we'll use async image. Select the one with the URL, string, title. That loads our images, but we desperately need some modifiers. Open brace, image in, enter 3 times. After the brace, type place, tab, progress view in the placeholder. Back inside async image, enter, .resizable, .scale to fit. We've seen these modifiers in our home view. The difference is we're going to add a frame to better contain it. After our placeholder, .frame, right arrow, select the one with width and height, do 120 for width and 200 for height. Alright, we're almost there. A frame is needed on the parent vstack itself. There are quite a few closing braces, but if you double click on the leading VStack brace, Xcode will show you where the closing brace is. After the closing brace, enter, dot frame, right arrow, only height this time, do 250. This constricts the view to have a max height of 250. We're pretty close to the edge. To fix this, we can add a padding modifier. This creates space. The default is 16 points. Put 10 in the parentheses for less space. Wow, we did a lot in this video. Great work as usual. Let's take a break, and I can't wait to see you in the next one. We're almost done with the horizontal list view. Before we use it in our home view, just a few final details. To begin, after the image scale to fit modifier, add the clip shape modifier. Inside the parentheses, type rounded, rectangle. Select the one with corner radius. Use 10. This modifier gives our images nice rounded corners, slightly more modern looking, in my opinion. Next, I would like header to be dynamic. If we use the view now, header can only be trending movies. This was great for testing. However, our view is finished and ready to be versatile. To do that, delete everything after header. Instead, type colon, space, string. This allows us to define a string for header when calling the view. Very helpful, since we'll have 4 different types of lists. There's an error in the file because our preview needs an argument for header. Scroll down, click on the error, select fix, click on the string, type constants, .trending movie string. This wraps up our horizontal list view. Before we put it in our home screen, navigate to constants, make some space after trending movie string. Let's define the rest of our headers. Static let trending TV string equals trending TV. Static let top rated movie string equals top rated movies. Static let top rated TV string equals top rated TV. Steer to home view. We want these titles after our buttons. Double click on the starting H stack brace to find the closing one. Make some space after the closing brace. Horizontal list view with header. Constants.trending movie string. Copy that line. Paste 3 times. Change the second one to constants.trending TV string. The third one to constants.toprated movie string. And the last one to constants.toprated TV string. The horizontal lists are displaying correctly with the right headers. However, our home view doesn't look the best. This is because the number of views exceed the phone screen. To fix this, we can add a scroll view to our parent view. This can easily be done by scrolling up, right-clicking on our VStack, select Embedded, Scroll View. Much better. While we're here, we should change the VStack to Lazy VStack. Lazy VStack is best here, as the views will load when they are needed. The home view layout is really close to being done. To finish up, I want to improve the hero title slightly. If we click on an empty line and hit space on our keyboard, this makes the view reload. Watching the hero title, it kind of just pops up. A frame modifier will fix this. We're going to need the size of the screen to pull this off. This can be done by using Geometry Reader. Right-click on Scroll View, Embed, Geometry Reader. After the braces, Geo in. Navigate to the placeholder closing brace. Enter, frame, right arrow, Select the one with width and height. For width, type geo.size.width. For height, do geo.size.height. This makes the frame the size of the screen. We can make this better by adjusting the height. Type times 0.85. To summarize, we embedded Scroll View into Geometry Reader. Geometry Reader got the available screen space minus the save space. We put the frame of our hero title to the full width of our available space. However, we only want the height to be 85% of the available space. Now if we test, the hero title doesn't jump on screen. As mentioned before, home view is close to being finished. Just a few more final touches, but we'll do them in the next video. Thank you for joining us. Can't wait to see you in the next one. We have all the elements on our home view. To finish, I'd like to add a gradient between the hero image and space after it. The first step is to define a new color. Navigate to Assets, right-click, New Color Set, Gradients. In light mode, the gradient should be white to match the space after our hero title. Thus, in dark mode, the gradient should be black. Select Dark, open the inspector, Color Set, Show Color Panel, 6 zeros, 1, 2, 3, 4, 5, 6, enter, close the color panel, close the inspector. Go back to home view, hit enter after the scale to fit modifier. Dot overlay with braces. The overlay modifier will put a view in front of our hero image. Inside the overlay braces, type linear, gradient. Select the one with stops, start point, and end point. We'll space this out a bit as it can get confusing. Right before the S in stops, press enter. Press enter again before the S in start point. Finally, enter before the E and end point. Double click on gradient.stop. Left arrow key once. Add an open parenthesis. Enter on the suggestion, color location. For color, use dot clear. Tab. 0.8 for location. The editor is recommending adding another gradient.stop, which is what we need. Press tab to complete. The second color should be dot gradient. Location should be 1. Press enter before the second G in gradient to space it out better. For start point, dot top. Tab. Endpoint will be dot bottom. Let's break this code down. Linear gradient creates a smooth transition between colors along a straight line. In this case, it transitions from clear to our custom gradient color. Linear gradient has 3 arguments. First is an array of gradient.stops. This defines the colors and their locations. Start point and end point define the direction of the gradient. In this case, it starts at the top and ends at the bottom of the async image. Picture 0% means the top and 100% the bottom. From 0 to 80, the gradient is clear or fully transparent. From 80 to 100, the gradient transitions to our custom gradient color, white or black, depending on the mode. We can see in our preview, the gradient really makes the design pop. I'll switch to dark mode. It looks just as awesome. This wraps up home view, but we have one more task left. We need to run this code to test. In order to run, home view needs to be called from content view. Open content view. Replace constants.homeString with home view. At the top toolbar, drop down your target devices. I'm going with the iPhone 16. Press Command R to run. If everything works, you should have our home view displaying on your emulator. We can scroll down to see all of our titles. Testing the horizontal list, they seem to work. A quick note, our play and download buttons work, but don't click smoothly. You have to long click to get the animations. This is because the buttons are embedded in the scroll view. The scroll view swipe gesture takes priority over the button animations. But don't worry, the buttons still work 100% of the time. This truly wraps up section 1. We learned a lot in these 9 videos. I want to say thanks for supporting this course so far. My team and I really appreciate it. Go ahead and take a break if you need it. You deserve it. Give yourself a pat on the back, and I'll see you in section 2. At some point in your iOS journey, you'll work with APIs or external datasets. Most of these rely on JSON objects to store and transfer data. Understanding how to model these objects in your SwiftUI projects is critical. By doing this correctly, you'll be able to use and display the data in your apps. This video marks the official start of section 2 in our SwiftUI beginner course. The main goal of this section is to fetch and display live data from the movie database API. We'll complete the first step in this video, modeling the JSON objects in our project. If you're just joining us, feel free to grab the section 1 code from our GitHub. The link will be in the comments. I do recommend having some experience with SwiftUI before starting this section. Section 1 of this free course is a great place to start. Let's take a look at our API data. This set is for training movies. The data contains an object, as shown by the top left curly brace. This object has an end called page and an array named results. The results array contains the data that we're interested in. From here, we can pick and choose what is needed for our app. For Blossom Movie, we need ID, title, overview, and poster path. Just a heads up, I tried original title at first, but got titles in their original language, Spanish and Japanese included. Now that we know what data is needed, it's possible to build a model. I'll navigate back to Xcode, Command N to create a new file, Swift file, next, title, create, make some space after import foundation, struct, title with braces. Struct is short for structure in SwiftUI. It's a lightweight and efficient way to group related data together. Type var id :int, enter, var title :string, enter, var overview :string, enter, and var poster path :string. We model title based on what we need from the results array. Before moving on, please make sure your spelling matches with mine. Misspelling is one of the most common mistakes when working with APIs. I want to show you one more thing with our data. This next set contains training TV. Notice title has been replaced with name. ID, overview, and poster path are still here, but it's important to see the slight difference. Keeping this in mind, I'll go back to Xcode, hit enter after title, var name :string. This will allow our title struct to also work with the TV data. However, what happens if our app tries to find a title string for TV data? As we saw, title is replaced with name in that set. The app will unfortunately crash because it's expecting a value for title. To fix this, we can mark name and title as optionals by putting a question mark at the end. This tells our struct that title and name may or may not have a value. If they don't have a value, instead of crashing, the app will assign nil to them. Nil means no value in Swift. Because this isn't data that we manage, it's a good idea to mark all the properties as optionals, just in case. The properties we need from the results array are modeled well here. Just a few more things. After title, type : decodable, comma, identifiable. This makes the struct conform to the decodable and identifiable protocols. Decodable allows title to be created from an external data source. Swift will automatically map the data to the struct's properties if the names match. Identifiable requires this struct to have an ID property that uniquely identifies each instance. This will be useful when we use title in our SwiftUI views. Our title struct is complete. In the API data, title was under an array called results. We need to do the same thing with our title model. Make some space before struct API object, decodable, with braces, var results, bracket title, bracket equals brackets. Instead of listing results as an optional, we set it as an empty array. That way, if the database returns nil, there's already an empty array there. I'll bring up the working data one more time and put it side by side with our model. Everything is matching up. We start with an array called results. This array contains a struct title, which has the properties we need. Good work on this one. This is a really important concept. It goes beyond iOS if you ever want to get into any other coding space. Great job again. I can't wait to see you in the next one. With our title model completed, we're ready to grab our API key. This key allows us to request and fetch data from the movie database API, after which we'll be able to display the data in our app. A quick word of caution. Safeguarding API keys is a broad topic that exceeds the scope of this course. While hard-coding keys directly into your code isn't recommended, we'll take a simpler approach for this practice app by storing them in a JSON file. This method does keep the key out of the source code, but it's not a production level solution. However, it's a good step towards better practices. In addition, it'll also teach us concepts like the singleton design pattern and error handling. The first step is to get our credentials. Open a new Chrome window. Inside the search bar, type the movie database. The first link will do. Click on login. Please create an account if you need to. I already have mine, so I'll just log in. Select user profile, settings, API. This is where your API key will be. If you just made an account, you'll need to generate a key. It's a pretty straightforward process and totally free. Once you have your key, keep it handy. We'll need it here shortly. Navigate back to Xcode. Command N for a new file. Scroll all the way down. Empty. Next. API config.json. Create. Please make sure the file is inside your project directory. This file will hold sensitive information like our API keys and base URLs. In turn, this sensitive information will be out of the app source code. Inside the JSON file, start with an open curly brace and hit enter. This creates an object. Type quotes, tmdb, base URL, quotes, quotes. I'll paste the base URL here. It'll be in the comments. Please copy and paste it as well. Close quotes, comma, enter. Quotes, tmdb, API key, quotes, quotes. Paste your own API key here. As a placeholder, I'll type in your key. Before we move on, please ensure your spelling lines up with mine. Caps as well. Our API config.json file is ready to go. It just contains two strings, the base URL and our API key. Hit Command N. Swift file this time. Next. API config. Create. API config.swift will be used for reading and accessing the contents of the JSON file. This allows us to dynamically load sensitive information, like our API keys, into our app at runtime. Make some space after import foundation, struct, API config, decodable, with braces. We have to include decodable because API config will be created by an external source. our .json file. Let tmdb base URL :string, enter. Let tmdb API key :string. These are the variables in our .json file. They have to match exactly. Hit enter a couple times. Type static let shared API config equals braces. At the end of the braces, put parentheses. We're using something called a singleton pattern here. This is a design pattern that ensures only one instance of API config is created. We're naming that one instance shared. Singletons are good for centralized resource management and usage. We know our logic goes inside the braces. The parentheses at the end are new. They immediately execute the closure at runtime. In turn, our credentials are available right away. Inside the braces, type guard let URL equals bundle.main.url. Select for resources with extension. In for resources quotes API config tab quotes JSON else braces fatal error API config.json is missing or invalid. We're trying to find the API config.json file in the apps bundle. If the file isn't found, the else blocks executes and fatal error will crash the app. This ensures the app can't proceed without the JSON file. Make room after the closing brace. Now that we found our file, we can get the data out of it. Type do with braces. After the closing brace, type catch with braces. The do catch block is used to execute code that might throw an error. This allows us to handle that error gracefully if thrown. Inside the do block, let data equals try data contents of URL, return try json.decode API config.self, from data. Inside catch, fatal error, failed to load or decode API config.json \error. The autocomplete was pretty good here. Let's break this code down. Load the contents of the API config.json file from the URL we made above. Try is needed here because data contents of can throw an error. After that, try to decode and return the data as an API config struct. This is done using a JSON decoder. The catch block only runs if an error occurs in the do block. Again, fatal error is used because that app can't run without this information. To finish up, we need to run the app to make sure this works. Navigate to Content View. Double click on the tab view starting brace. Click on the closing brace. Enter. .onAppear with braces. Print API config.shared.tmdb base URL. Below that, print API config.shared.tmdb API key. Go ahead and run this code with Command R. If everything works, you should have the base URL and API key showing in your log. If your app crashed, please double check all the files we created. Misspelling and capitalization are the common mistakes. Right now, the app crashes if there's an issue with the .json file. In the next video, we'll explore a more user-friendly way to handle this error. Thank you for spending time with us today. We truly appreciate your support. Can't wait to see you in the next one. Handling errors is a key part of your iOS development journey. Whether you're connecting to a backend or loading a JSON file, errors will definitely pop up. In this video, we'll refactor our code to gracefully handle errors. Currently, our file uses fatal error. This was good to help us understand how to load our API credentials, but it's not a long-term solution. Let's dive in and learn how to handle errors better. We'll start by creating a new file to keep all our errors organized. Hit Command N on your keyboard, Swift file, next, errors, create, make some space after import foundation, enum, API config error, :error, comma, localized error with braces. This is the first time we've seen an enum. Enums are used for grouping related values together in a way that's easy to manage and use. Think of them like a list of options or categories you can choose from. In this enum, we'll list all the possible errors related to our API config. We've also made our enum conform to the error and localized error protocols. Error allows the enum to be used for throwing errors in functions. Localized error enables us to provide more user-friendly messages or logs. This makes it easier to debug issues. These two protocols help our enum handle and describe errors in a clean way. Inside the braces, type case, file not found, enter, case, data loading failed, parentheses, underlying error, :error, right arrow key, enter, case, decoding failed, underlying error, error. These are the three issues that can cause errors in our API config file. The file isn't found, the data doesn't load, or there is a decoding issue. The data loading failed and decoding failed cases both include an underlying error. This is because these errors can occur for multiple reasons. For example, data loading failed might happen because the file is corrupted, or maybe the app doesn't have the right permissions to read the file. By including the underlying error, we capture the exact system error and use it for debugging. To finish the file, we can include user-friendly error descriptions. Hit enter a couple times after the last case, var, error description, hit tab to autocomplete. If we pause for a second, the editor will recommend finishing the property for us. Hit tab to autocomplete again. The editor did a pretty good job completing this property. Please make sure your file looks like mine. The error description string gives a better error description for each of our cases. When we get a data loading failed or decoding failed case, we include the error's localized description to see what went wrong. A quick note, the error description string isn't optional because it conforms to the localized error, which is also an optional. Our API config error enum is complete, and now it's time to put it to work. Navigate back to api-config.swift. To start, let's organize the loading and decoding logic by placing it in its own function. After the parentheses, make some space, private, static, func, load, config, parentheses, throws, return arrow, API config with braces. A quick recap on functions. The private keyword restricts its function's access to only within the API config file. This ensures the logic for loading can't be called directly from outside. Our singleton shared is static, which means it could be called anywhere in the project. Therefore, the function must also be static, since it'll be going inside the singleton. Load config is the name of the function. Throws allows the function to throw errors if something goes wrong, such as a missing file. Finally, the return arrow indicates the function returns an instance of API config once everything is loaded and decoded correctly. Next, let's move the loading and decoding logic into our function. Start from the last catch brace and highlight everything up until the guard statement. Command X to cut. Click inside our function and press Command V to paste. Replace the first fatal error with throw API config error dot file not found. In the catch statement, add let error as decoding error. Replace the second fatal error with throw API config error dot decoding failed underlying error error. We specify the error as decoding error to know exactly what went wrong with the decoding process. Decoding errors are really specific, and this helps us better debug if needed. Add another catch statement with braces. Inside type throw API config error dot data loading failed underlying error, error. With this, we successfully integrate our enum to handle potential issues gracefully. Instead of crashing the app with fatal errors, we now catch and safely return descriptive errors. To finish this file, update our share singleton to be an optional. Inside the braces, write a do catch block. Inside do, return, try, load config. Try is needed because load config can throw errors. In the catch block, print failed to load API config error.localize description. After the message, return nil. This is why we made our share singleton an optional. If there's an error during setup, share will be nil, allowing the app to handle the situation without crashing. All that's left is to test. Go to our content view, delete the old print statements, type if let config equals API config.shared with braces, print config.api key, print config.base URL. Because API config.shared is an optional, we have to unwrap it to use it. Unwrapping means we check if it's empty or nil. The if let statement checks if it's nil, and if it isn't, we print the properties. Command R to run. If you're showing your API key with the base URL, everything went fine. But very quickly, let's simulate an error. Go to API config, and in the with extension argument, add an extra n. Command R again to run. This time, we're showing the error we defined. The API config file can't be found because the extension is mistyped. Most importantly, our app didn't crash. Very good. Please delete the extra n so everything works as expected. That's it for this video. Thank you all so much. Can't wait to see you in the next one. In the last lesson, we focused on handling errors gracefully to make our app more reliable. With that foundation in place, the next step is to start building functions that will decode our server data. To begin, head over to Content View and delete the onAppear block. This was a placeholder for testing and no longer needed. Next, navigate to our errors file. Here, we'll create a new enum to manage and categorize any network-related errors. Make some space after the closing brace. Enum, network error, error, localized error, brace. Inside the braces case, bad URL response, parentheses, underlying error, error, enter, case, missing config, enter twice, var, error description. If your suggestion from the editor matches mine, press tab to autocomplete. Once again, the editor's autocomplete gives us the correct structure. Press tab to save some time. This is similar to our API config error enum above. The case bad URL response will trigger if the application encounters an issue with the server response. Some examples include a wrong website address, a server error, or a response that doesn't match the expected format. Case missing config triggers if something goes wrong with the configuration of our API config file. We'll need this when we unwrap our API key and base URL. By handling these scenarios, we ensure our app can gracefully manage unexpected issues during network requests. With our enum ready, we can make a new file to hold our network functions. Press Command N, Swift file, next, data fetcher, create. Our file is ready. Hit enter once after import foundation. let tmdb base URL equals API config.shared.tmdb base URL. Enter. Let tmdb API key equals API config.shared.tmdb API key. We define the variables globally so that all of our functions can access them. Since the singleton API config.shared is optional, these variables are optionals as well. This ensures that if there's an issue decoding the API config file, our app won't crash, but handle the missing configurations. Hit enter a couple times after API key, func, fetch, titles, parentheses 4, media, :string, close parentheses, async, throws, return arrow, bracket, title, bracket, braces. Let's break down this function. We know that fetch titles is the name. It takes one parameter, a string called media. The 4 in front of media is called an argument label. Argument labels make the function call more descriptive and easier to understand. We used 4 here, but you can use any word that fits your use case. Async throws means this function will run on a different thread than the main thread and might throw an error. This is important because as a network call, we don't want it running on the main thread with the UI. Doing so can lead to performance drops and a less responsive app. Finally, the return arrow indicates that this function will return an array of our title model. The purpose of this function is to connect to the URL and attempt to fetch the titles inside. The first step in this function is to build the URL where our data is located. To give you a better idea, I'll paste an example of what the URL should look like for trending movies. It starts with our base URL, followed by several directories, and ends with a query that includes your API key. To continue, we need to unwrap our TMDB base URL and TMDB API key. Inside the function, guard let base URL equals TMDB base URL else with braces. Inside the braces, throw network error dot missing config. Below that, guard let API key equals TMDB API key else with braces. Same thing, throw network error dot missing config. These checks ensure that TMDB base URL and TMDB API key are not nil. If they're available, they'll be assigned a base URL and API key respectively. However, if either of them are nil, the function will stop and throw the network error.missing config case. This will signal an issue with the configuration. With our base URL and API key values unwrapped, we can build the URL. Make some space, let fetch titles URL equals URL, parentheses string, base URL, question mark, enter, dot appending, parentheses path, quotes 3 / trending, backslash, parentheses media, parentheses / day, enter, dot appending, parentheses query items, bracket, enter, URL query item, name, parentheses API underscore key, tab, API key. This builds the exact URL we have at the top. It adds the paths, including the media string and the parameters. Then, it appends the query items, including our API key as an argument. Query items are pairs of information added to the URL to send data to the server. Quick note, we use a question mark after the URL because the URL string initializer returns an optional. This means that if the string is invalid, the code will safely return nil instead of crashing. At this point, our URL is complete and ready to use. You've done an excellent job laying the groundwork for fetching data. In the next video, we'll build on this and complete the function. As always, great work. In the last lesson, we started building our fetch titles function and created the URL containing trending movies. In this lesson, we'll complete the function by handling the API response and parsing the JSON data. First, let's fix a sneaky mistake in our URL. We forgot a / after trending. Without the slash, trending movie would be combined and the URL won't work. To help us debug when we run the code, add print fetch titles URL. This will print the URL in our console and allow us to inspect it. We do get a warning because fetch title URL is an optional. To safely unwrap it and handle potential failures, we need to update our network errors enum. Open the errors file. Inside network error, under missing config, case, URL, build, failed. After adding URL build failed, we'll see an error because any switch statement handling network error now requires this new case. Click on the error, fix. The code for our .url build failed can simply return failed to build URL. With our new case added, we can go back to data fetcher, add guard in front of lat to safely unwrap our URL. At the end of the parentheses, else with braces. Inside the braces, type throw network error dot URL build failed. This ensures that if our optional URL is nil, we throw our new case, preventing potential issues down the line. We can finally start parsing this response. Make some space after our print statement. Let parenthesis data, comma URL response, parentheses equals, try, awaits, URL session, dot shared, dot data from, fetch titles URL. Let's break this code down. This function returns two values, data, which is the actual raw JSON data from the API, and URL response, a URL response object that contains metadata about the request. This could include an HTTP status code, which tells us whether the request was successful or not. These values are assigned to the variables data and URL response, respectively. Try is needed because this function can throw an error. For example, if the network is down. Await means this is an asynchronous operation, so the function completes in a separate thread without blocking the app. URL session is a built-in class in Swift that handles network requests. .shared is a singleton instance of URL session, meaning we don't have to create a new session manually. Finally, .data from fetch titles URL makes a network request to the URL we built earlier. It downloads the data from the API and also gets a response from the server. Next, we need to check if the URL response is valid. I'll scroll down and hit enter a couple times. Guard let response equals URL response as question mark HTTP URL response, comma, response dot status code double equals 200, else, braces. We first check if the URL response above is a valid HTTP response. If it is, the HTTP URL response is assigned to response. Then we check whether our response variable has a status code of 200. A 200 status code means that everything went well and the request was successful. If either of these checks fail, we can throw network error dot bad URL response underlying error any error. Since we don't have an existing error to pass, we need to create our own using NS error. NS error stands for next step error, an Objective-C class used to represent errors in Apple's framework. Select the NS error that includes domain, code, and user info. We can put domain, code, and user info on their own line to avoid clutter. Domain represents where the error is coming from. In this case, parentheses data fetcher works because the error comes from this function. Code is the status code from the URL response. We can attempt to get this code using parentheses URL response as question mark HTTP URL response parentheses dot status code question mark -1. If a status code exists, we use it. If there is no status code found, we default it to -1, indicating an unknown issue. User info is a dictionary containing additional error details, such as a descriptive error message. We can use brackets and s localized description key, quotes, invalid HTTP response. This ensures that if the response is invalid, we throw a readable error that helps identify the issue. I'll scroll down for more room. We check to make sure the response was valid. Now we can define our decoder. Click outside the guard statement. Let decoder equals JSON decoder. A quick note, our variable poster path follows camel case, meaning the second word starts with a capital letter. In the API, they use snake case, meaning words are separated by an underscore, like poster underscore path. To account for this difference, we can add decoder dot key decoding strategy equals dot convert from snake case. This tells the decoder to automatically convert snake case keys from the API to camel case. Finally, we can complete the parsing. Type return try decoder dot decode API object dot self tab from data parentheses dot results escape. Since decoding can fail, we need to use try in case an error is thrown. The decode function takes an object type and tries to convert the raw URL data into that object. In this case, we're decoding the data as our API object struct. Remember that API object contains an array called results. This results array is made up of multiple title structs, where each struct represents an individual movie or show with its properties. By returning results, we get a fully decoded array of titles that we can now use in our app. I know this was a lot to take in, and some parts might have been a bit confusing. Feel free to rewind and revisit any explanation if you need to. Also, if you have any questions, don't hesitate to ask. I'll do my best to help. You're doing an amazing job, and the fact that you made it this far speaks volume about your dedication. That's it for this lesson. Thank you so much. I can't wait to see you in the next one. View models are a key concept, not just in SwiftUI, but across many frameworks. Their job is to handle data, while the UI focuses on managing the interface. Separating these responsibilities is a common practice and an essential skill for any developer. In this video, we'll demonstrate how to build a view model. The first step, of course, is to create a new file. Make sure to select the Blossom Movie folder, press Command N, Swift file, next, view model, create, hit enter for space. It's important that our view model instantly updates the UI whenever the data changes. Therefore, we need to include the @observable macro. @observable allows this view model to automatically notify the UI of any data changes. We typically can't use a struct with @observable because structs are value types. This means a new copy is created whenever they change. Instead, we can define our view model as a class. Now we can share and modify data without creating new copies. Inside our view model class, we'll define an enum to represent the different stages of the fetching process. Enum, fetch status, with braces, case not started, case fetching, case success, case failed, parentheses underlaying error, :error. Before making a request, we start with case not started, where the UI remains empty. Once fetching begins, the state switches to fetching, displaying a progress view. If fetching succeeds, we show the normal UI. However, if an error occurs, we'll display a view with the error message. With our enum created, we can now use it in the view model. Down arrow after the enum closing brace and hit enter. Private, parenthesis set, parenthesis var, home status, fetch status equals not started. Private set ensures that only the view model can update home status. Other parts of the app can only read its value. This is important because only view model will know the value for home status based on the response. We initialize it with not started because no request has been made yet. The next step is to define our data fetcher. Before that, we need to navigate back to the data fetcher file and convert it into a struct. At the top after import foundation, hit enter, struct, data fetcher, open brace, scroll to the bottom, and add a closing curly brace to complete the struct. This was something I forgot to do in the earlier video, and I apologize for that. The good news, you get to see how we fix mistakes in real time. With data fetcher fixed, we can return to our view model file, press enter for a new line, private, let data fetcher equals data fetcher. A quick note, private isn't required here, but since no other file needs access to data fetcher, it's good practice to include it. That way, when we call structs in other files, we're only presented with relevant options. Next, we'll create an array to store our trending movie titles. New line, var, trending movies, bracket, title, bracket, equals, brackets. The trending movies array will hold a list of title structs. We initialize it as empty to ensure our app doesn't break if no data is returned. With the property set for now, we can move on to creating our functions. Make some space and add func, get titles, parentheses, async with braces. Async is used because this function will make a network call. This allows it to run on a separate thread, preventing it from blocking the main UI. At the start of the getTitles function, we could type home status equals .fetching. When this function is first called, it will allow us to display a progress view to show loading. Next, we can add a do catch block, since the function we're about to call can throw errors. Inside do, trending movies equals try awaits, data fetcher .fetch titles for movie. Remember, data fetcher .fetch titles returns an array of decoded title structs. We pass a string argument movie to build a URL for trending movies. This is useful because in the future, we'll need to fetch trending TV shows the same way. If this completed successfully, we can say home status equals .success. This tells our UI to show the home view. We just need to handle any errors. I'll scroll down first and add print error. This prints the error to the log for debugging. Now we set home status to .failed, passing error as underlying error. This gives us an error message that we can have the UI show. This is a simple view model, but we covered the core concepts of how it works. We just have a few more steps before we can see it in action, but we're almost there. Thank you very much for spending some time with me today. I can't wait to see you in the next one. In-out parameters are useful when you need to modify a value inside a function and have that change persist. Normally, function parameters in Swift are constants, meaning they can't be changed. With an out, you can pass a variable into a function and have it change directly. In this video, we're going to apply this concept to complete our view model. Inside our view model right now, we're successfully getting the trending movies. However, each image from the API is only half complete. Let's jump into the constants file to see what's going on. The API only returns the last part of the image URL. To display the full image, we need to add the URL beginning part ourselves. We're going to create this in-out function inside our constants file. Let's first define the poster path beginning. I'll scroll down. I'll also make some room after test title URL 3. Type static let poster URL start equals tab. The editor might recommend it for you, but if not, you can just copy and paste it from above. We can delete the ending /. It's already included in the API response. Right arrow, hit enter a couple of times for space. Now we can define the function, static func, add poster path, parentheses 2, titles, colon, in out, bracket, title, bracket parenthesis, with braces. This function is static because we need another part of the app to access it. The function name is add poster path. We use the argument label 2, making it clear that we're adding the poster path to the titles. The titles parameter is an array of our title struct. The in-out keyword signals that this array goes into the function, gets modified, and comes back out with the changes applied. I'll scroll down a bit more. Inside the add poster path function, type for index in titles.indices with braces. This loops through all the titles in the array and gives us the index of each one, allowing us to modify them directly. Inside the for loop, add iflat path equals titles bracket index.poster path with braces. This checks if poster path is nil. If it has a value, we assign it to the variable path and modify it inside the braces. Otherwise, we just leave it nil. We can finally complete the modification. Inside the iflat statement, enter titles bracket index dot poster path equals constants dot poster URL start plus path. This takes the existing poster path, combines it with the base URL, and updates this value for each title in the array. Our function is complete. Let's use it in our data fetcher file. Scroll down to our return statement. Instead, type var titles equals. This stores the titles in an array, allowing us to modify it before returning the data. Now we can apply our in-out function to complete the poster path for each title before returning the array. Make a new line and add constants dot add poster path to titles, return titles. The and before titles tells Swift, modify the actual array, not a copy. This allows our function to apply changes directly, as we discussed earlier. We're complete with the in-out function, but we have time for one more thing. Navigate to our title file. We're going to create an array of sample data. This sample data will help us when we go back to the UI and work with our previews. Make some space after var poster path. Type static var preview titles equals brackets. Inside the brackets, type title. Down arrow to our struct. Right arrow. Select the one that has all the properties. This will ensure our sample data matches the actual structure of our API response. I'm going to space this out by pressing enter before title and after the closing parenthesis. This makes the code easier to read. Now copy this line. At the end of the line, type comma, enter, and Command B to paste. Do it one more time. This gives us 3 tile structs to work with. We just need to fill in our data. It's going to be pretty simple. Just follow along. Click on the first ID, 1 tab Beetlejuice, tab Beetlejuice, tab a movie about Beetlejuice, tab constants dot test title URL. I'll do the same for Pulp Fiction. Start at ID, 2, Pulp Fiction, a movie about Pulp Fiction, constants.test title URL 2. Finally, we just need The Dark Knight, 3, The Dark Knight, a movie about the Dark Knight, constants.test title URL 3. That wraps up this video. We learned about in-out functions and even got our sample data ready. I know we stepped away from SwiftUI for a bit, but in the next lesson, we're coming back with an important topic, the infamous, depending on who you ask, model view view model, or MVVM pattern. Thanks for spending some time with me today. The model view view model pattern is a popular design choice for many reasons. It helps keep your code organized by separating UI logic from business logic, making it more maintainable and easier to test. Like most things in coding, it's a bit controversial, as some developers argue it's unnecessary in SwiftUI. In my experience, MVVM shines in complex projects, helping clean up loaded files and making code more structured and readable. Even though Blossom Movie is small, applying MVVM will give us experience, so you can decide if it's the right pattern for your own projects. To recap, our model is represented by the title file. This file defines the API object and is used for decoding our API response. There's also sample data to help us with our SwiftUI views. While we're here, it doesn't hurt to fix a typo. Moving on, we have the data fetcher file. This file acts as a service that holds our network logic. It contains the fetch titles function, which connects to our API, retrieves the data, and decodes it into a title array. Next, we have our view model. It includes an enum to track the fetch status, initializes a data fetcher, and stores an array of trending movies. Inside the getTitles function, it calls fetch titles to populate the trending movies array. Thanks to the @observable attribute, the view model automatically updates the UI whenever the data changes. To complete the MVVM pattern in this project, we need to connect the view model to our UI. First, open the horizontal list view file. Right now, it contains a static array of poster strings. Remove everything to the right of var titles. Replace it with : bracket title. This allows us to define a title array when calling this view, making it dynamic. We get a few errors, the first one being because we use .self as the ID in our for each loop. Our title struct already conforms to the identifiable protocol, so we can remove id.self. To fix the next error, use the title poster path property for the async image URL. Remember, all the title properties are optionals in case they're known in the API. Therefore, use a double question mark operator to provide an empty string if the value is missing. A default URL will be a better approach, but an empty string works for now. We have one more error in this file. The preview requires an array of titles to compile. Scroll down, click on the error, and select Fix. This adds the titles parameter, which we can set to title.previewTitles to resolve the issue. Our sample data coming in clutch. We're ready to go with this file. There are a few more errors to address, but before we fix them, open API config.json. Replace your key with your actual API key from the movie database. I'll be doing this off camera, but please make sure to do this as the code won't work without it. If you need help getting your key, check out my API keys video for guidance. With that done, navigate to Home View. Under Hero Test Title, add let viewModel equals viewModel. This creates a new viewModel that will control the UI. Press Enter after the scroll view brace. Type switch. Pause for a second to see if Xcode auto-completes it. If it does, press Tab to start the switch statement. Pause, then press Tab again to auto-complete the rest. It's always nice when Xcode helps us out. However, my switch statement isn't quite right. I need to change the third case to .success. For now, I'll leave an empty text in there. Next, I need to add the last case, .failed, let error. Inside this case, I'll simply add text, error, \error. To break it down, we executed a switch statement on the viewModel.homeStatus When case is .not started, we show an empty view. With .fetching, a progress view appears. In .success, we currently have a text placeholder, but we'll add our UI here soon. Finally, in .failed, we display the error as a text on screen. Let's scroll down to fix the error that's showing. Click on the error and select Fix. This adds the missing titles array. Inside that, type viewModel.trendingMovies. Select the other three horizontal list views and comment them out using command /. We pass the viewModel trending movies to our horizontal list view, which will display them. Although right now, the trending movies are empty. Now scroll up and double click on the lazy VStack brace. Reselect everything from the ending brace back to lazy VStack. Press Command X to cut. Inside the .success case, select the text and paste with Command V. If the case is .success, the UI will not be displayed. The last step is to make sure the viewModel populates the training movies array. Double click on scroll view's open brace. On the closing brace, add .task, braces. Inside .task, type await, viewModel.getTitles. The .task modifier runs an asynchronous task when the view appears, allowing await viewModel.getTitles to fetch data without blocking the UI. This is the moment of truth. If your preview builds and you can scroll down to see the trending movies list, you're good. Scroll to the right and take a moment to appreciate how fast and smooth it scrolls. This whole section has been leading up to this moment. If you're not so lucky, we'll troubleshoot now. Press Command R to run the app. I got the simulator up and the list is working great. Open your log and the first thing to check is the API address. Copy and paste it to an empty browser window. You should see data returned just like mine. If you don't see data, check your API address to make sure it wasn't mistyped. Also verify that your API key is valid. You might also have configuration issues. Compare your code to the completed version to find any mistakes. Misspellings in the title struct or API config.json are also common issues. This wraps up the video. Great job making it this far. We've learned a lot in the course so far and even implemented a clean MVVM design. I'll end it here, but I can't wait to see you in the next one. If you're not careful, a function can quickly get out of control, especially when you start using it for different tasks. To help combat this, helper functions in Swift can keep your code clean, organized, and easier to manage. We'll cover an example of using a helper function in this video to show how it can help simplify your code. Currently, we're fetching training movies from our API using the fetch titles function. Since training TV has the same URL, the only change needed is swapping movie for TV. But we also need to fetch top-rated movies and TV shows. These calls have slightly different URLs, meaning modifying our fetch titles function. Let's open Data Fetcher and take a look. I'll paste the URL for top-rated media right after the training URL. The URLs are similar, with the main difference being the order of media and type. For example, the first URL uses trending/movie, while the second uses movie/top rated. Additionally, trending includes day before the API query, whereas the latter places top rated before the query. Since only the URL changes, we can keep the same function, add a parameter, and update the logic to build the appropriate URL. We could add that logic directly inside this function, but it would get big fast. Looking ahead, we'll also need this function for our search screen. Therefore, using a helper function now is a better approach. First, let's add the new parameter. After for media string, put a comma, add by type :string. This lets us specify the media as either movie or TV and choose between trending or top rated as a type. Now we can make our helper function. Double click on the fetch titles closing brace, add a couple lines, type private func build URL parentheses media :string comma type :string parentheses throws return arrow URL question mark with braces. We mark the function as throws, allowing us to throw error enums when needed. Inside the helper function, we need to unwrap base URL and API key. Lucky for us, this is complete already. Scroll up, cut the first two lines from fetch titles, paste them inside the build URL function, make some space, and add var path :string. This path will be used to construct the correct URL based on the type. I'll scroll all the way down for more room, add a couple lines, if type double equals parentheses trending parentheses braces path equals parentheses 3 / trending / parentheses media parentheses / day else if type double equals top _ rated braces path equals parentheses 3 / parentheses media parentheses / top _ rated else parentheses throw network error .url build failed. With the path correctly made, we just need to build the URL. We got lucky again and already completed this. Scroll up to the fetch titles function and cut the guard let statement. Paste it under the else statement and build URL. Let's rename fetch titles URL to just URL. Also, replace the hard-coded path in .appending with our path variable. Below the guard let statement, add return URL. This completes the build URL function. Let's put this new function to work by scrolling up one more time. Before the print statement, type let fetch titles URL equals try build URL media type. We just need to unwrap since the build URL function returns an optional. Guard let fetch titles URL equals fetch titles URL else braces throw network error dot URL build failed. I'll fix our spacing. That completes our fetch titles function, allowing it to fetch both trending and top rated titles. Without the build URL helper function, this logic would stay inside fetch titles, making it messy and harder to maintain. Please try to use helper functions whenever they make sense. To wrap this up, go back to view model, add the missing parameters for our fetch title call. We can put parentheses trending. That's it for this video. Thank you for spending some time with me today. I'll see you in the next one. When making multiple async calls, using try await for each one can slow things down. This is because each call must finish before the next one starts. To improve speed, we can use async let, allowing each call to run parallel instead. In this video, we'll demonstrate how to implement async let using Blossom Movie as an example. Our view model currently only fetches trending movies. We still need to get trending TV shows, top rated movies, and top rated TV shows. The hard part is already done since our fetch titles function is set up to handle different URLs. Now we just need to put it to work. We can start by defining our new arrays, make a line after trending movies, type var, trending TV, colon, bracket title equals empty brackets, enter, var, top rated, movies, colon, bracket title equals empty brackets, enter, var, top rated, TV, colon, bracket title equals empty brackets. Like the trending movies, we create these lists as empty in case the API returns them null. Next, scroll down and press enter after the try await closing parentheses. We'll call data fetcher to populate our new arrays at trending TV equals try await data fetcher dot fetch titles for TV by trending top rated movies equals try await data fetcher dot fetch titles for movie by top underscore rated top rated TV equals try await data fetcher dot fetch titles for TV by top underscore rated. From here, we can open home view, go down, uncomment the horizontal list views by selecting them and pressing command /. Errors appear because we need to pass an array for the different views. Click on the first error and press fix. Add view model dot trending TV. Click on the next error and press fix. Add view model dot top rated movies. We just need the last error. View model dot top rated TV. Our preview updates, and if we scroll down, the rest of our titles appear. We've put in some work, and our app is pretty well organized, making this addition seamless. Press Command R to run the code. Scrolling down to the right, all the titles load pretty quickly. I'm going to close the app a couple of times and reopen it to test loading speed. Not gonna lie, it's actually pretty fast. Keep in mind this is a small app with only 4 network calls going so far. As we add more to it, it might slow down with our current async setup. Let's see if we can improve it by going back to view model. I'll close the log. Right now, we're using try away for each call. This means training movies runs first, training TV waits until it's done to start, and so on with the other calls. To speed things up, we can use async let. Starting with training movies, highlight everything to the left of data fetcher, replace it with async let tmovies equals. We can do the same for training TV. Async let tTV equals. Moving on to top rated movies. Async let TR movies equals. And finally, async let TR TV equals. Now we can update training movies to try OAT movies, training TV to try OAT TV, top rated movies to try OAT TR movies, and finally, top rated TV to try OAT TR TV. By using async let, the calls run in parallel instead of each one waiting for the previous one. Press Command R to run the app. We have our app ready. I'll do the same test a couple of times, closing the app and reopening it. The app is slightly faster, but as mentioned, this could really make a difference with more network calls and a bigger app. We'll stop here. Thank you for spending time with me today. I can't wait to see you in the next one. API network requests are one of the most performance taxing and expensive things your app can do. It's important to think about how often you need to make a request and adjust your code accordingly. In this video, we'll rethink how our app is conducting calls and modify it to fit the correct profile. In our viewModel class, we have our getTitles function retrieving our data from the API. The issue is that the titles are retrieved even if the list is already populated. This results in more network calls than we need since our data doesn't update consistently. If this was a chatting app, it would make sense. Let's run the code to see. We can scroll down to see the titles populate. If we change the tab to upcoming and go back to home, the view is back to the top. This is because the getTitles function repulled the titles. With this API, it's unlikely the data changes that fast. When the user opens the app, populating the titles there is enough. We can fix this in our viewModel class. Scroll down. Right after home status equals .fetching, make a new line. If trending movies dot is empty, open brace, scroll down to the catch statement, enter, add a closing brace. This makes sure the API is called only if trending movies are empty. Type else with braces after the if statement. Home status equals .success. This lets our viewModel know that the lists are populated and to set the UI normally. Hit Command R to run. Now scroll down to load the titles. Press upcoming and go back to home. The titles didn't repopulate, making our API calls more efficient. It's a good idea to think about the calls you're making and how you need them. There's one thing left before wrapping up. Go back to the viewModel. Make sure you're inside the isEmpty block. Change the home status to fetching. This will keep the UI loading. Run the code. The progress view is sitting in the corner looking odd. To fix it, open Home View. Select Progress View. Add the dot frame modifier. Width and height. Set the width to geo.size.width. Tab geo.size.height. Run. Much better. Let's reset our status to .success in the view model. Run the code one more time. This is a big moment. Section 2 of the course is officially completed. We've been uploading this section for about 2 months. I want to thank you all for the support. It really means a lot to us. Section 3 will cover navigation. Can't wait to see you there. Most of the time when you're working with navigation, you'll go into some kind of detail screen as your second view. That usually means showing more information about whatever you're displaying on the main screen. In our case, we've got a list of titles, therefore, we'll navigate to a screen that shows more details like the name and description. In this video, we're going to create this detail screen. Then we'll be ready for navigation in the next one. The first step is to create a new file. Hit Command N, SwiftUI View, Next, Title, Detail, View, Create. Make some space after line 10. We want to define a title variable to build our view. Let title:title. Make more space. Our preview needs a title argument. Click on the error. Fix. We can put in title.preview titles (0). This takes the first title from our preview titles array. Our sample data coming in clutch. I'll also show the canvas to help us build the view. Now we can build how the information will be displayed. Delete the famous hello world. And set type geometry reader, geometry in. We're going to display the title image for now, but move on to a YouTube video later. Geometry reader allows us to get the size of the screen for this view. Next, type scroll view with braces. Some of the titles have pretty long descriptions. In case this happens, scroll view will allow us to scroll down. Moving on, type lazy vstack, alignment and content, leading, tab, press enter for braces. This lazy vstack aligns its elements to the left of the screen and loads them when needed. Now we can declare our async image, select the one with URL, parentheses string, title.posterPath, ? quotes. We unwrap the title poster path and give an empty string in case it's nil. Add an open brace, image in, press enter a few times. After the closing brace, placeholder, progress view. This adds a nice progress circle as the image loads. Inside the async image braces, we can add modifiers, image.resizable, .scale to fit. Finally, add a dot frame modifier after the closing placeholder brace. Dot frame, width and height, geometry.size.width, tab, geometry.size.height, times 0.85. This frame keeps a place for the image as it loads. With the image ready, we can show some text. Text, double parentheses, title.name, ? title.title, ? parentheses, bold, font, title2, dot padding 5. We try both the name and title first. If they are both nil, then we just leave it as an empty string. After, we apply modifiers to make it look better. I would like the title closer to the image. Dot padding dot top, comma, -20. Now we just need to display the description, text, title, dot overview, question mark, quotes, dot padding 5. This is a very simple detail screen, but it shows everything in the title struct except for the ID. As we move on, we'll add a download button and the YouTube video in place of the image. Fun fact, to make this screen, we had to use a little bit of everything from the course we've learned so far. Thank you for joining me. See you in the next one. Navigation is extremely important in SwiftUI. This is because you'll want users to go to different screens in your app. Currently, the latest and greatest way to achieve this is with Navigation Stack. In this video, we'll show how it works by implementing it in Blossom Movie. We're going to start by seeing how buttons can drive navigation. In our app, we have a hero title showing on the home screen. The play button is meant to take the user to our title detail screen. Right now, the title is just static, so the first step is to show a different title every time the user opens the app. Since the app is called Blossom Movie, we'll use a different title from our trending movies list. Make sure you're inside View Model. Under Top Rated TV, add a line. Type var hero title equals title dot preview bracket 0. This defines a new title called hero title. We initialize it using the first title in our sample data. By doing this, we'll have a fallback, and we'll need to unwrap it later. Scrolling down, make a couple lines after Top Rated TV. If flat title equals trending movies dot random element braces hero title equals title. This makes sure trending movies dot random element isn't nil before assigning it to hero title. We're all done here. Open home view. Delete hero test title with command delete. There's an error inside async image because hero test title doesn't exist anymore. Replace hero test title with view model dot hero title dot poster path question mark quotes. Poster path is an optional, so we do need to unwrap it. Just an empty string works for now. The picture will just be a progress view if nil. Press Command R to run. Nice, the title changed. I'll close and reopen the app to make sure it changes each time. Keep in mind, we're getting a random title from trending movies. Therefore, we might have some repeats. Step 1 is complete. Now we can get into the navigation. After we define our view model, type add state, private, var, title, detail path, equals navigation path. Add state means the UI can change this variable. Navigation path helps us manage where the user goes in our app. I'll close the log. Now we can embed our geometry reader in a navigation stack. Make sure your canvas is open so we can use a shortcut. I'll adjust the canvas. Right-click on Geometry Reader, Embed, Navigation Stack, parentheses path, $, title detail path. Navigation Stack starts with your main screen and lets you navigate to new ones, kind of like stacking pages on top of each other. Path, $, title detail path tells SwiftUI which screens we visited. so it knows where to go and how to go back. Moving on, inside the play button action, we can put title detail path, append, view model, hero title. This adds a new screen to the stack using hero title as the data for that screen. We do get an error because our title struct doesn't conform to hashable. To fix, open title.swift. After identifiable, put a comma. Hashable. Hashable lets Swift tell if two items are the same. This is required when using navigation path. Let's go back to home view, and the error is gone. We can close the canvas. The last thing we need to do is add a navigation destination. Find the closing brace of our lazy V stack, make some space, navigation, destination, select for destination, title.self, tab, enter, title, tab, title detail view, title. This tells SwiftUI, when we push a title onto the stack, show the title detail view with that title. It's how SwiftUI knows what screen to show when we use data pending with the title. Hit Command R to test. Alright, our app is ready. Let's press the play button. Nice, it works. We can scroll down for the rest of the description. Our layout isn't the best. That's what I get for listening to the canvas and not testing. It's an easy fix. Open title detail view. Delete the negative padding. Run it again. Now press play again. Much better. That's all for this video. Thank you for watching. There's a good chance you'll be showing some kind of list in your app. When an item of that list is tabbed, it's common to navigate to another screen, passing the item data. In this video, we'll show how to achieve this using navigation paths. We want to keep the navigation logic inside home view. To do this, the tabbed item needs to be accessible here. Open horizontal list view, press enter on line 12, type let, on select, title, return arrow void. On select is the closure property that takes a title and returns nothing. The title we pass will be accessible to home view, allowing it to handle navigation. Keeping that logic inside the parent view helps prevent nasty bugs. Now we need to pass the tab title to our onSelect property. The best place to do this is right before the for each loop ends. Here, we still have access to the title that was tapped. Click the end of our .frame modifier, make a new line, .onTap gesture, onSelect, title. We just need to fix our preview, scroll down. After the closing parentheses, open brace, title in, press enter a few times. This tells a preview, do nothing with the tab title. With this completed, we can go back to home view, scroll down. We have some errors to fix due to our new onSelect property. After the closing parentheses, add an open brace, title in, enter ×2, inside the braces, title detail path, append, title. As a quick reminder, title detail path is a navigation path we defined on top. .append puts our tab title struct into the title detail path. This allows it to be displayed in title detail view, defined below with .navigation destination. We just need to fix the other 3 horizontal list view errors. Let's copy the closure we used with trending movies. Paste it for the next 3. Always good to save some time. Before we test, we can cut our .navigation destination modifier. Paste it right under our .task modifier. It's good practice to have this modifier as close to the navigation stack as possible. This helps us see the navigation more clearly. Go ahead and run the code with Command R. Let's click on our first trending movie. Nice, it works. Let's go back and do some more testing. I'll just click on a few. Good. We're able to click around and go back to our home screen. Let's also make sure the hero play button works. Do it a few times. No issues here as well. A slightly shorter video, but if you're not careful, nasty bugs happen with navigation. These can include duplicate screens and views not being dismissed. That's it for this one. Thank you for watching. You might want to display a web page or maybe a YouTube video in your iOS app. WebKit is a perfect tool to help accomplish this. This is a UIKit tool, and at the time of this recording, there's no native way to do this in SwiftUI. In this lesson, we'll set up a web view to display a YouTube video. This will get us one step closer to fetching and displaying trailers for each title. Before we get started, I want to point out it's not a good idea to keep sensitive information directly in the client. For production apps, Firebase Cloud Storage or a secure backend would be a safer option. However, this is a practice app that won't be published. The goal here is to focus on learning and get better with SwiftUI. With that out of the way, let's open our API config.json file, add a comma after TMDB API key, enter, type parentheses YouTube, base URL, parentheses colon, parentheses https colon youtube.com/embed. This will be the URL we use to show our YouTube videos. Next, open API config.swift. After TMDB API key, press enter. Let YouTube base URL colon string. This gives us access to the YouTube base URL string throughout our app. Please make sure your spelling matches with mine before moving on. Make a new file with Command N. Swift file. Next. YouTube. Player. Create. We don't need import foundation here and can replace it with import SwiftUI. Also add import WebKit. Add a couple lines. Type struct YouTube player colon UI view representable with braces. UI view representable lets us wrap a UIKit view and use it inside SwiftUI. Inside the braces, type lat web view equals UK web view. Enter lat video ID colon string. Enter lat YouTube base URL equals API config.shared.YouTube base URL. UK web view creates an instance of a web browser, but inside the app, we'll use the video ID and YouTube base URL to load our videos inside it. Make some space and type func. Make UI view context return arrow sum view UI view. Inside the braces, type web view. This function is part of the UI view representable protocol. It's called once our SwiftUI view is created and tell SwiftUI, this is a UI kit I want you to use. In our case, show the web view we just made. Down arrow once, add a couple more lines, func, update UI view, UI view, UI view type, context with braces. Another part of the UI representable protocol. This one gets called whenever SwiftUI updates the view. We'll load our video here into the web view. Inside the braces, type guard lat base URL string equals YouTube base URL, comma, enter, lat base URL equals URL, parentheses string, base URL string, else, bracket, return. This first unwraps the YouTube base URL string from our API config, ensuring it's not nil. Then we convert the string into a URL, also making sure it's not nil. If either of them are nil, we safely exit the function. Below that, add lat full URL equals base URL dot appending path, video ID, enter, web view dot load URL request, parentheses URL, full URL. We complete our YouTube URL by appending the video ID. Then we have web view load this URL. This completes the file. Let's now open title detail view, delete async image, add YouTube player, video ID, paste this ID in there. It's one of our most popular YouTube shorts. Add the modifier dot aspect ratio, select aspect ratio and content mode, 1.3 for aspect ratio, tab dot fit for content mode. This modifier makes sure the video keeps the correct shape and scales proportionally. 4:3 or 1.3 is the YouTube Classic embedded video ratio. Hit Command R to run. The simulator is up. Click on any movie title. Perfect. We have our web player showing front and center. Press play. Need an SF symbol, and it works. Right now, all the titles will have the same video, but the next step is to work with the YouTube API to get the trailers for each title. Thank you for watching this video. See you in the next one. Google, along with Apple, is one of the main forces in the mobile development space. As an iOS developer, there's a good chance you'll use a Google product at some point. This could take form with Google Auth, Firebase, or Google API. In this video, we're going to start working with the YouTube API. This includes getting our API key from the Google Developer Console, as well as modeling the return JSON data. The first step in our journey is to get our credentials. Open your favorite browser, type Google Developer Console in the search bar, open the first link. If you haven't already, please make yourself a Google account. Once you have one, click on Create Project. I'll call this project Blossom Movie. Create. With the project created, navigate to Library. Find YouTube Data API v3. Open it. Enable. Now we just need to create credentials. We're going to be using public data. Next. We have our key ready to go. Go ahead and copy it. Let's go back to Xcode. Open api-config.json. Put a comma after YouTube base URL. Enter. Parentheses YouTube. API key. parentheses, colon, double parentheses. Please paste your API key in here. I'm going to put in your key as a placeholder. While we're here, we might as well define the YouTube search URL. Add a comma after the YouTube key. Enter, parentheses, YouTube, search, URL, parentheses, colon, parentheses. I'll paste the URL here to save some time. It'll be in the description if you want to grab it. With our new properties in the JSON file, we just need to define them in api-config.swift. Make a new line after YouTube base URL. Let YouTube API key colon string. Enter. Let YouTube search URL colon string. Please make sure your spelling matches with mine before moving on. The next step is to model our JSON data. I'll bring up an example of what a YouTube search call returns. This is the data we're working with. We're going to conduct a YouTube search on the title name and the word trailer. The only element that interests us here is video ID inside the items array. This video ID will be passed to our YouTube player to show the trailer. We'll simply use the first ID as it's most likely to be the correct video. Let's head back to Xcode, Command N for a new file, Swift file, next, YouTube, search, response. Great. I find it easier to start from the bottom when modeling a nested dataset. Struct, ID, properties, colon codable, with braces, let, video ID, colon string, question mark. This models the last layer, getting our video ID. It's a good idea to make these properties optionals in case the database returns nil. We can go to the next layer up, which is an object named ID. Make room at the top of ID properties, struct, item properties, colon codable, let, ID colon ID properties, question mark. We just need the top layer, struct, YouTube search response, colon codable. The top layer has an array that contains item properties. Therefore, we can type let items, colon, bracket, item properties, bracket, question mark. The struct names themselves don't matter as much as the property names. Property names have to match the JSON data or else the app will crash. I'll bring up our working data one more time. Starting from the top, we have an array of items that contains an object called ID. Inside ID, we're able to get the video ID. We're all done here. Everything is set up, and the next step is to parse the data. Thank you for watching. Something about programming is that although rewarding, it tends to be a bit repetitive. For example, in our app, we already saw how to model an API response, build a URL, and parse the response. In the pursuit of working with the YouTube API, we already modeled the response. Now we must complete the next two steps, building the URL and parsing. This will be the main topic of this video. It's good to remember that practice does make perfect. To start, open datafetcher.swift. We need to define our new variables under TMDB API key. Let YouTube search URL equals API config.shared.YouTube search URL. Enter. Let YouTube API key equals API config.shared.YouTube API key. To recap, our end goal is to show the YouTube trailer for each title in the details screen. By using the YouTube API, we can get the trailer video ID and pass that in the YouTube player we made earlier. Now we can create a function to build a URL and parse the data. Scroll all the way down, click after the second to last curly brace, hit enter a couple times. We'll make this its own function since it's a different API. Func fetch video ID parentheses for title :string close parentheses async throws return arrow string. This function takes in a string called title. It also makes a network call and could throw an error, therefore async and throws are needed. The function returns a string at the end. Inside the braces, we need to first unwrap the YouTube URL and key, guard lat, base, search, URL equals YouTube search URL, else, braces, throw, network error dot missing config, down arrow, enter twice, guard lat, search API key equals YouTube API key, else, braces, throw, network error dot missing config. The next step is to build our URL. I actually want to show a different way to accomplish this without hard coding like we did in the movie database. Open constants. Right after the closing brace, make some space and scroll down. Enum YouTube URL string :string with braces case trailer equals parentheses trailer case query shortened equals parentheses q case space equals parentheses space case key equals parentheses key. Using enums this way to group related strings helps prevent typos, encourages reusability, and keeps things neat. I wanted to show a better way than just hard coding the values. I used this method in another project and it's been pretty good. It should actually be YouTube URL strings. Going back to data fetcher, under search API key, let trailer search equals title plus YouTube URL strings dot space dot raw value plus YouTube URL strings dot trailer dot raw value. This is one query we'll make to the API. Make some space. Time to finally build our URL. Guard lat fetch video URL equals URL parentheses string base search URL dot appending query items URL query items. Press enter. After the first bracket, press enter. Press enter again after the closing bracket. This spaces it out, making it easier to read. We can now add our query items. I'll scroll down a bit first. Add a parentheses after URL query item. Select name and value. For name, YouTube URL strings dot query shortened dot raw value tab trailer search. Right arrow, add a comma to add another query item. Press enter first for better spacing. URL query item, name and value, YouTube URL strings dot key dot raw value tab search API key. We just need to complete the guard let statement. After the closing parentheses, else with braces, throw, network error dot URL build failed. After we build the URL, add print fetch video URL. This will help us check the URL in the console. To help us see this more clearly, I'm going to paste the URL that we just built using Breaking Bad as an example. The first part is our base URL. We then add our first query, represented by the queue and the trailer search string we built. The second query is our API key. I did want to tackle parsing in this video, but I actually think this is a good place to stop for now. Thank you for watching. Parsing API JSON responses is one of those things that keeps coming back. We've already seen how to do it with the movie database, but this time, we're taking it a step further. In this video, we're going to refactor that code and make it reusable using Swift generics. With the refactored code, we'll be able to parse our YouTube API response. We can open Data Fetcher to start. Parsing the response in our fetch titles function starts from let data URL response till var titles. This code will be similar to parsing the YouTube response, the only difference being what object we return. We could just copy and paste the code down to our fetch video ID function. However, this is the perfect moment to introduce Swift generics. This can also be good code for later projects. Let's make some space after the fetch title closing brace. We'll make the function here first, test it, then call it for the YouTube response. Func fetch and decode, left arrow t colon decodable, right arrow, parentheses URL colon URL, comma type colon t dot type, parentheses async throws, return arrow t with braces. T colon decodable lets the function know that the struct we're working with must conform to decodable. We pass in two arguments, a URL and a struct using t.type. T.type means we're passing a generic struct that we want to decode, like API object.self. The function will perform a network request and can throw an error, which is why async and throws are needed. Finally, it will return a struct represented by t. Select from let data URL response to var titles, cut with Command X, paste it inside our fetch and decode function. We just need some adjustments. Replace fetch titles URL with URL. Delete var titles equals at the end. Replace with return. API object should be t.self. Finally, delete .results. We replaced our hard-coded values with the arguments we passed into the function. Here's a quick recap of what this code does. We use try await URL sessions that share that data to fetch data from the URL passed into the function. This gives us both data and a URL response. Then, we unwrap the response and make sure it's a HTTP URL response with a 200 status code. If it's not, we throw a custom next step error that describes what went wrong. After that, we define a JSON decoder and tell it to use .convert from snake case. This is needed since our JSON keys are snake case, but our Swift structs use camel case. Lastly, we use that decoder to try and return the object type t from the URL data. T is the generic type we pass into the function. We can actually replace this with type since we already defined the variable. Now we just need to call this function and fetch titles. Click under print fetch titles URL, var titles equals try await, fetch and decode, fetch titles URL, API object.self, .results. Going back to title.swift, remember that API object has a variable called results, and that's where the titles live. I think a rename is in order because we're now working with two APIs. Right-click API object, refactor, rename, add tmdb at the front, enter. Navigate back to datafetcher.swift. To clean up our struct a bit more, let's move the helper functions to the end. Select fetch and decode and build URL. Command X, paste them under fetch video ID. The final step is to use our new function to finish fetch video ID. Select after the print statement, make some space, return, try, awaits, fetch and decode, fetch video URL, YouTube, search response, .self, .items, .first, .id, .video ID, question mark, quotes. We pass in the YouTube search response struct this time. Remember, the struct is pretty nested. It returns a list of items, so we grab the first item in the array. From there, we drill down to video ID, chaining each level with a question mark to safely unwrap. If anything in the chain is nil, we return an empty string using a double question mark operator. We're done with parsing the API responses. The fetch video ID func isn't hooked up anywhere, but we can still test to make sure our new function works for fetch titles. Please update your TMDB key inside API config.json before running. Hit Command R. Our simulator is up and everything loaded correctly. Click around to make sure everything is working. Good job with this. Thank you for watching, and I'll see you in the next one. In our app so far, we've done a lot of legwork to get the YouTube API going. After modeling, URL building, and parsing, all that is left is to hook everything up. Although slightly controversial, we'll be using model, view, view model to get everything up and running. Lucky for us, we've already built the MVVM structure in our app. That was the hard part. Adding more logic is much easier. Open viewModel.swift. Press enter after the home status enum. We'll make a new enum to keep track of the video ID fetch state. Private. Set var video ID status :fetch status equals .not started. Let's press enter to space it out better. Make a new line under hero title. Var video ID equals quotes. We'll use this property to hold the string that our YouTube API fetches. Find the closing get titles brace. Press enter a couple times after it. Func get video ID for title :string async with braces. This function will be called in the UI to retrieve the video ID. We can set the status to fetching when called. Video ID status equals .fetching. Create a do catch block under that. This will help us handle errors. Inside do, we can call the API video ID equals try awaits data fetcher .fetch video ID for title. Video ID status equals .success. We set this if everything goes well. Inside catch, we can print the error to our log. In addition, set the status to .failed Don't forget to pass the error for underlying error. This completes the view model. All that's left is to hook it up to our UI. Open title detail view. There are a few things I want to do here to make our code better on top of adding the feature. To start off, let's create a computer property of our title name. Make a new line after title, var, title name, :string, with braces. Inside the braces, type return, parentheses, title.name, title.title, parentheses, quotes. This is the first time we've seen computer properties. It's a great way to add custom logic to your models without storing extra data. This logic tries to return the name or title first. If they are nil, an empty string is returned instead. Our API uses names for movies and titles for TV shows, so we test for both. Under this computer property, make a new line, let viewModel equals viewModel. Our viewModel will control the UI depending on the API call result. Find the closing brace in scroll view. From the closing brace to the open brace, press Command X to cut. This code will be used if the call succeeds. Inside the geometry reader brace, type switch viewModel dot video ID status. Xcode completes the cases for us. Inside .started, put empty view. We can tab over. .fetching will just show a progress view. Add a line and add .frame, width and height. For width, geometry.size, .width, tab, geometry.size, .height. This puts the progress view in the center. Inside case.success, paste the UI code we cut. Replace video ID inside the YouTube player with viewModel.videoID. We can also use title name inside text. Finally, inside case.failed, type text underlying error.localized description. For now, we just show what error took place, but we'll make this more user-friendly later. The last thing to do is to call our viewModel to fetch the video ID. After the geometry reader brace, make a new line, .task with braces, await, viewModel.getVideoID for title name. Before we test, please make sure you update your API keys in API config.json. Hit Command R to run. The app is ready. Click on the play button from the hero title. Nice. The video loads, and it looks like it grabbed the correct trailer. Press play. And it works. Go back. Let's try a trending TV title. Perfect. Also looks great. Just a heads up with the YouTube API. Google limits the API calls per day. If you open enough titles, you'll get an error at some point. That's it for this video. Thank you so much for watching. With making iOS apps, there's a good chance you'll need different style of list. We already saw how to make a horizontal list. In this video, we'll make a vertical list in SwiftUI, expanding our toolset. Let's start by making a new file with Command N, SwiftUI view, next, vertical, list, view, create. Click on line 10, enter, We can define an array of titles to use for the list. Var titles, :bracket title. We get an error because the preview needs a list of titles to use. Select the error, fix, pass title, .preview titles. Make a new line after titles. Delete the famous hello world. List, parentheses titles, parentheses bracket, title in. Inside the list braces, async image, URL, parentheses string, title, .poster path, question mark, quotes. We make a new list and pass our titles in. Then we show each title poster with async image by converting the poster path to a URL. Modifiers are needed on our async image. Right arrow twice, bracket image in, enter. Right arrow, placeholder, progress view. This shows a progress circle as the image loads. If the poster path is nil, we pass an empty string that just keeps the progress view going. Go back in the async image brace, image, enter, .resizable, .scale to fit, .clip shape, .rect, corner radius, 10, .padding, 5. These modifiers allow the image to be resized to fit within the space given, make the corners round by a radius of 10, and add space around at 5 points. We want the title names to be next to the poster, therefore, right-click on image, embed an H-stack. Make some space after padding 5, text, parenthesis, title.name, question mark, title.title, parenthesis, question mark, quotes. A title can have a name or title property depending if it's a movie or TV show. We try both, and if they're nil, an empty string is passed. Let's add a couple of modifiers to the title. .font, .system, size 14, .bold. By putting our title inside the async image closure, it won't show unless the poster loads. Click after the placeholder brace, enter, .frame, height, 150. This keeps the list items no more than 150 points tall. Since no width is specified, each item takes up as much space needed horizontally. The list looks great. We can use it in our app, but only with sample data for now. Make a new file with Command N, SwiftUI view, next, upcoming, view, create, delete hello world, vertical, list view, titles, title, .preview titles. This seems like overkill to just call this in our content view. In the future, there will be logic here that can make our content view messy. Navigate to content view, delete text contents upcoming string, replace with upcoming view. Press Command R to run. Our app is up and running. Click on upcoming. Nice. We have our sample data showing as a vertical list. We still need to add navigation and, of course, real API data. This is the first time we work on another tab in the app, so great job. We're done here. Thank you for watching. At this point in the tutorial, our vertical list is built. However, it's still only showing test data. In this video, we'll populate it using our API and display a list of upcoming movies. Open Data Fetcher. I'll paste the URL we'll populate our vertical list with. This URL is identical to our top rated URL, with the only difference being upcoming instead of top rated. We'll have to adjust our build URL function To construct this correctly, scroll down. Inside the else if statement, type or type double equals upcoming. Replace top rated with backslash parentheses type. This will build the correct URL when top rated or upcoming are passed for the type. To make our code a bit better, delete trending in the first if statement, backslash parentheses type. The less hard-coded strings, the better. Our build URL function can now make the upcoming URL. With this, we can open our view model, make a new line after video ID status, private, parentheses set, var, upcoming status, fetch status equals .not started. We'll use this enum to keep track of the upcoming title's fetch state. A new array is also needed to hold the upcoming movies. This can be placed after top rated TV, var, upcoming movies, colon, bracket title equals empty brackets. By making this array empty, we won't need to unwrap it later. Since this call will not be on the home screen, we can make a new function for it, scroll all the way down, make some space after the get video ID function, func, get upcoming movies, parentheses async with braces. Inside the braces, we can set upcoming status equal to .fetching. Then we can make a do catch block. Inside do, upcoming movies equals try await, data fetcher, fetch titles for movie by upcoming. Try is needed because this function can throw errors, and await allows it to run in the background, not blocking the UI. If this call completes, upcoming status equals .success. Now we just need to complete the catch statement. Print error. Upcoming status equals .failed, underlying error, error. We print the error in our console for debugging, and then pass the error in our enum for the UI. Everything is ready to go here. We just need to hook it up to our UI. Open upcoming view.swift. Make a couple of lines after line 10. Let view model equals view model. Delete the preview titles. Replace with view model upcoming movies. Make some space before this line. Switch view model upcoming status. This allows us to define a view for each state. In .not started, we can put empty view. Fetching is progress view. Cut the vertical list view code. Paste it inside .success. Lastly, text, underlying error, .localized description, works great for case.failed. The progress view should be in the center of our view when it loads, before the switch statement. Geometry reader, brace, geo in. Delete the closing brace. Put it after the switch closing brace. Add a frame in progress view. .frame, width and height, geo.size, .width, geo.size, .height. This puts the progress view in the center of the screen. All that's left is to populate the data, find the geometry reader closing brace, enter .task with braces. Inside the braces, await, view model, .get upcoming movies. This populates the upcoming movies array. Before running, Please make sure to update your API keys inside apiconfig.json. Hit Command R to run. Our app is up and running. Navigate to Upcoming. Nice. The data populates. We can scroll down, and everything is in working order. If you're thinking, it's getting easier to set everything up, you'd be right. A lot of the infrastructure was done in Section 2, allowing our new features to be added faster. That's it for this video. Thank you for watching. Navigation is a critical aspect in any app. Like most things, there are a few ways to accomplish this. We already saw one way by using navigation stack and navigation path in the home screen. In this video, we'll demonstrate how to use navigation links with navigation stack for the upcoming screen. To start, let's open the parent view, which would be upcoming view. We need to embed this view into a navigation stack. Right-click on Geometry Reader, Embed, Navigation, Stack. This allows us to enable navigation within our view. For example, tapping a list item can now push a new screen into the stack. The next step is to define a navigation link inside the child view. Open vertical list view. Make some space before async image. Navigation link with braces. Define a label after the closing braces. Inside the navigation link braces, we need to define our destination. Title, detail view, title, title. This passes the title tabbed before going to title detail view. Label defines how the navigation link is shown. The UI for the vertical list will do great. Select from async image till dot frame. Cut. Paste it inside label. To recap, we added navigation stack to the parent view. Then, we added navigation link inside the child view. Navigation link lets us define where the user goes and how the link looks using label. Please make sure the API keys are updated inside apiconfig.json. Press Command R to run. The app is up. Select Upcoming. Notice there are arrows on the right showing a clickable list. Click on the title. The title detail view opens correctly. I'll test a few more titles. Everything seems to be in working order. Let's go to the Home tab while on a title detail in the Upcoming tab. Click on the title. Go back to Upcoming. The detail screen maintained in Upcoming. If we go back to Home, the detail screen also maintained there. I do want to talk about navigation path versus navigation link to finish the video. Although navigation link is much simpler to use compared to navigation path, it comes with a few drawbacks. First, it's a little too eager to make the views. This can happen sometimes even when an item or button isn't tapped. Therefore, performance issues can occur. Second, navigation link only works with user interaction. You can't use it to navigate after loading data or handling things like deep links or push notifications. That means no async navigation and no programming control. All that being said, navigation link does work and it's really simple to use. I think it's good for practice apps where the point is to work on other big features and keep navigation simple. However, for production apps, I would lean towards navigation path to keep performance and overall user experience tight. I wanted to show you both ways to give you more options. That wraps up this video. Thank you so much for watching. We officially finished the second tab on the app and are pretty close to completion. I can't wait to see you in the next one. We've seen how to build horizontal and vertical lists in this tutorial. Sometimes, your app might instead need a grid layout with rows and columns of content. That'll be the main topic for this video, creating the UI for a grid style list. This is going to be the third tab of our app that will contain the search feature. Therefore, we'll need to create a new file, press Command N, SwiftUI view, next, search, view, create, make some room after line 10. We'll define an array of titles here that will populate the list. Var titles equals title dot preview titles. For now, our sample data works great. Go ahead and delete the famous hello world. Instead, type scroll view with braces. This screen will later return a list of titles from a search. Therefore, we want a scroll view in case the search results exceed the screen capacity. Inside the scroll view, type lazy vgrid, down arrow and right arrow to see more options. Select the option with columns and content. Lazy vgrid allows the items to stack vertically into columns. Lazy means this grid will load elements only when they are needed on screen. Columns is an array of grid items that define how many columns our grid has. For this grid, 3 is perfect, meaning we need to add 3 grid items. Select grid item, press enter, add a set of parentheses before the closing brace, comma, grid item, parentheses, comma, grid item, parentheses. We could have defined different spacings and other properties for the grid items. However, just a simple version is good for our needs. Tab over to content, press enter to complete the closure. The content of our lazy vgrid can go inside these braces. For each, open parentheses, titles, close parentheses, bracket, title in, enter twice. This loops through our titles list and gives us access to each element. For each element, just the movie poster is good. Put your cursor inside the for each braces, async image, URL, parentheses string, title, dot poster path, question mark, quotes. We convert the poster path string into a URL and also safely unwrap it. If it's nil, an empty string is passed. A placeholder is needed for our async image as it loads. Add an open brace at the end. Image in. Press enter a couple times. After the closing brace, placeholder, enter, progress view. This shows a progress circle while the image loads. Now we can add modifiers to our async image. Inside the braces, image, enter, dot resizable, dot scale to fit, dot clip shape, dot rect, parentheses corner radius, 10. These modifiers allow the image to resize into the allowed space while keeping good aspect ratio and rounding the corners. To finish this off, we can add a frame for each of the images. Select the closing placeholder brace, enter, dot frame, select the one with width and height. Width will be 120 points and height will be 200 points. This allows the images to only be within this frame. Our lazy vgrid is complete. We can scroll down on the list if more elements get populated. It's a shame our sample data only has 3 titles, so we can't see how the next row looks like. Don't worry, real data will populate here soon. We can run a quick test. Open up Content View. Delete the text inside the Search tab. Search View. Make sure your API config has the movie database key. Command R to run. Our simulator is up and running. Click on the search tab. We have the grid showing. That wraps up this video. Thank you so much for watching. There's a good chance you'll need a toolbar at some point in your app. It's perfect for storing buttons, setting a title, or even housing a search bar. In this video, we'll build a SwiftUI toolbar and add simple logic to make it dynamic. We can start by adding a title first. For this feature, the main view needs to be inside a navigation stack. Inside Search View, right-click on Scroll View, Embed, Navigation, Stack. This is a great first step, as we'll need navigation later for this view. The rule of thumb when adding a navigation title is to be as close to the navigation stack as possible. The closest we can get is after our scroll view. Find the scroll view closing brace. I'll scroll down, press enter after the brace, dot, navigation title. It's tempting to hardcode the title in there. However, a good habit is to have the strings in one place where we can manage them better. It'll also make adding logic easier. Open constants.swift. Make some space after the top rated TV string. Static let movie search string equals quotes movie search. Make a new line. Static let TV search string equals quotes TV search. In our view, we'll be able to search for either a movie or TV show. Therefore, we want the title to change depending on what's selected. In addition, we'll also need two icons. Scroll down, hit enter after the download icon string, static let TV icon string equals quotes, copy, and paste it below. Change the second TV to movie. Click inside the TV icon string quotes. The SF symbol name goes inside here. I happen to know the name is just TV. Select inside the movie icon string quotes. Command-Shift-L. The icon for movies is going to be the clapper that says we'll take there in. Search for clapper. Press enter, and the SF symbol name gets filled out. A good trick if you ever need to search for SF symbols. Our strings and icons are ready. Go back to searchview.swift. Inside navigation title, put constants.movie search string. The title looks good. We also need a button to toggle between a movie and TV search. Press enter after navigation title, dot toolbar with braces. I'll scroll down. Inside the braces, we can define a toolbar item. Select the one that has placement and content. Placement is where the toolbar item will be. Dot top bar trailing. This puts the item on the right of the bar. Tab over to content and press enter. Inside these braces, we can define what's in the toolbar. Type button with braces. After the closing brace, label. Press enter to autocomplete. Label lets us define how the button looks. In this case, the button will be an SF symbol. Type image, system name, constants dot movie icon string. Nice. We get the image on the top right. Our toolbar is looking good. We just need to add some logic. When the movie icon is tapped, the title and icon should switch to TV. For this, a new variable is needed. Scroll up. Make a new line after var titles. At state private var search by movies equals true. Add state allows the UI to change its variable. Private allows only this view to access the variable. Private isn't absolutely needed here, but it's good practice to keep everything scoped to what they need. With our new boolean, we can scroll down to the toolbar item. Inside button, type search by movies .toggle. Now when the button is pressed, search by movies will go from true to false and vice versa. To finish the logic, we need both the navigation title and icon to depend on our boolean. Before constants.movie search string inside title, search by movies, question mark, after constants.movie search string, colon, constants.tv search string. We use a ternary operator where if search by movies is true, then show the movie search string. If it's false, then show the TV search string for the navigation title. Copy the ternary operator logic, paste it as the system name variable. Just use movie icon string and TV icon string. This completes the logic. We can test this inside our preview. Nice. Everything is in working order. This is a great place to stop. Our UI has an awesome toolbar and some logic to help in the later stages. Thank you for watching. I'll see you in the next one. Search bars are a common feature in iOS apps. They can help filter and organize data for the user. In this video, we'll add a search bar to our UI and construct the API search URL. To start off, we'll need new string constants for our search bar prompt text. This text will be displayed when the bar is empty. Open constants. Make a new line after TV search string. Static let movie placeholder string equals quotes search for a movie. Copy and paste the line we just made. Switch out movie for TV. Search for a TV show. We'll need these two since we'll be switching between a movie search and TV search. Go back to search view. In addition to these new strings, we also need a variable to hold what the user searches. Make some space after line 12. At state private bar search text equals quotes. At state allows the view to modify the variable. We use private because no other file will need to access this variable directly. All the precursors are ready. Scroll down and find the toolbar closing brace. Enter dot searchable. Choose the one with text and prompt. For text, we can put $search text. This creates a binding. Whatever the user types in the search bar gets synced into our search text variable. Tab over to prompt, search by movies, question mark, constants, dot, movie placeholder string, colon, constants, dot, TV placeholder string. We see the ternary operator here, allowing us to display the correct prompt depending on the type of search. Please update your API keys in api-config.json. Press Command R to run. Our app is up. Navigate to the search tab. Nice. Our search bar is showing. We can toggle it back and forth. Everything is working correctly. I do want to point out how easy it was to add the search bar thanks to SwiftUI. In addition, we were able to use .searchable because our view is inside a navigation stack. If we didn't use a navigation stack, for example, if we were in a sheet, then we would have to make the bar manually, which isn't too bad. We can get the ball rolling on hooking up the search bar to our API. A good place to start is to build the URL. Open Data Fetcher. I'll paste what a search call looks like. This one is a bit different than the rest of the URLs we've built so far. The word search is before the media type, and there are two queries: the API key and the movie or TV show we are searching. In this example, it's the movie Pulp Fiction. With this accounted for, we can scroll down to our build URL function. Click after the else if closing brace. Hit enter a couple times. Add else if type double equals quotes search with braces. Copy the path from the first else if statement. Paste it inside our second else if. Switch around type and media. I'll backspace else so it chains correctly. Admittedly, these chaining if statements aren't the prettiest. It would probably look better with a switch case statement. Maybe we'll go back and tighten up our code in a future video. To wrap up, we just need to handle our second query item for the search URL. In the arguments, add a comma after type, search, phrase, :string, question mark, equals nil. This argument is optional with a default value of nil, allowing the function to be used without a search phrase. Scroll down before we make the URL. Make some room before the guard let statement. Bar URL query items equals brackets. Copy the API key query item and paste it inside our new array. Every API call needs this API key query item to work. Now we can add the second item only if search phrase isn't nil. Make some space, if let, search phrase with braces, URL query items that append URL query item, name and value. Name will be quotes query. Value will be search phrase. Now we can pass the new URL query items in our URL. This successfully puts the search query into our URL only if it's needed. Unfortunately, we can't see the search URL in action just yet, but we are getting closer to adding the feature. We'll continue in the next video. Thank you for watching. View models in SwiftUI are surprisingly controversial. That's because SwiftUI was designed with state management baked right into the view. In my experience, as the app grows and networking calls come into play, view models can help manage responses and keep the UI focused. We already have a view model in our current app. However, this view model is working with the home, title detail, and upcoming screens. To keep things better organized, we can make a new one to just focus on the search screen. Hit Command N, Swift file, next, search, view, model. Great. Like our first view model, this one also needs to observe changes to its properties and communicate them. To do this, we can type @observable class search view model with braces. We're using a class here because it's a reference type, meaning changes to its properties reflect everywhere it's used. We've used enums to keep track of the different fetching states so far in the course. For this view model, we'll keep it simple and start with an optional property in case an error occurs. Private set var error message : string question mark. Private set allows only this file to set the value of error string while still allowing others to read it. We'll also need an array of titles to store the results. Private set var search titles colon bracket title equals empty brackets. Making the array empty ensures it's ready to use and won't need to be unwrapped later if something fails. The last property we need is an instance of our data fetcher to make the API calls. Private let data fetcher equals data fetcher. It's completely private here as no other file will need access to it. Let is also used because it won't change. Our properties are ready. We can now make our function. Func get search titles by media colon string for title colon string async with braces. Media will change depending if you are in a TV search or movie search. Title is a search term the user will enter in the search bar. Async is used as this function will be making a network call. Inside our function, write a do catch block. Let's go reverse and fill out the catch block first. Print error message equals error dot localized description. This prints the error to our log and assigns a user-friendly message to our error message. We'll display the error message in our UI later. Inside the do block, error message equals nil. If title is empty, search titles equals try awaits data fetcher dot fetch titles for media by trending. We first clear out any error messages. Title is going to be what the user types into the search bar. If the search bar is empty, we'll return a trending list of movies or TV shows, depending on what the user is searching. After the if statement, type else with braces. Before we can fill out this else statement, we do need to make an adjustment. Open data fetcher. Currently, our fetch titles function doesn't have a way to add a search term. We can fix this by adding another parameter. After string, add a comma with title colon string question mark equals nil. This creates an optional parameter called title and assigns nil if it's not used. Title will be how we pass our search term. With our new parameter, we just need to adjust the build URL call. Add a comma after type, search phrase colon title. Our build URL function was made to complete the search URL only if search phrase is not nil. With this adjustment, go back to search view model. Inside the else block, search titles equals try awaits data fetcher data fetch titles for by width. For will be the media passed in the arguments. We can pass search in for by. Width will be title. In hindsight, it would probably be better to group our parameters with enums. If we were working with a team, they most likely wouldn't know to pass in the string search or trending for the different API calls. Just some feedback for our own code. This completes our search view model. All that's left is to wire it up to the UI. We'll tackle this in the next video. Thank you for watching. Delaying an API call or debouncing is a great way to build an efficient search feature. Using this method can help prevent unnecessary requests every time the user types. In this video, we'll demonstrate how to complete an async search bar using debouncing. With our view model ready, we can now hook it up to our view. Open search view. Make a new line after search text. Private let search view model equals search view model. This view model will hold our titles and error if there is one. Let's complete the search bar logic first. Scroll down. After .searchable, add .task. Select the one with ID and action. For ID, add search text. Tab. Press enter to complete the closure. This task modifier will rerun the task inside anytime search text changes. Search text is bound to the search bar. Therefore, anytime the user types, a new API search will trigger. Inside the code block, type try await task.sleep 4.milliseconds 500. This adds half a second delay after the user stops typing. Without the delay, our API will get called after every keystroke, which isn't ideal. Make some space. If task.isCancelled, return. Here, we exit early if the task was cancelled to avoid running outdated searches. That can happen if the user keeps typing after stopping, causing the text to change mid-task. Now we can add our API call. Await search view model dot get search titles by search by movies movie TV for search text. We use await because the function is asynchronous, meaning it runs in the background. The call will look for either a movie or TV show, depending on the mode, with the search text. This completes our search bar logic. We also need to add the API call when toggling between a movie or TV search. Highlight and copy line 51. Scroll up to the trailing toolbar icon. Add a task block after toggling the boolean. Paste the API call in it. The task block allows us to call an asynchronous function inside a place that usually doesn't support await. In our case, inside a button tab. Just a couple of more things before we can test. Scroll up. Delete the titles inside for each. Replace instead with search view model dot search titles. We can use these titles as they will get populated with our API calls. Don't forget to delete the titles property as our sample data is no longer needed. The last thing is to display our error if one happens. The best place to have this error is right before our lazy B grid inside the scroll view. Add a couple lines before then. If let error equals search view model dot error message inside the braces text error dot foreground style dot red dot padding dot background dot ultra thin material dot clip shape dot rect corner radius 10. We added some styling to our error text. If let is great here, as if no error exists, the view will get drawn like normal. That completes this view, and we're ready to test. Please update your API keys inside apiconfig.json and hit Command R. Our app is up and running. Click on the search tab. Nice. Our grid view populates with default titles. I'll try to search Harry Potter. Good stuff. Let's cancel. And some default movies pop back up. Toggle for a TV show. Harry Potter. Now returns TV shows. I'll search instead for one of my favorite TV shows, Breaking Bad. There it is. I do want to show how the error looks like off screen I'll delete the movie database API key and run the app again. The app is back up with no API key, and we have an error on the Home tab. We did install this error, and it shows. Navigating to search, the error looks much better here. It scrolls up and down with our view. I do want to talk about some ways this screen can improve to wrap up. If we search for something that doesn't give results, an error saying no search results would be nice. In addition, a default image when the titles don't load would be better. Right now, we just have a progress circle that doesn't stop spinning when this happens. We won't be adding these features, but if you want to try, please feel free. Navigation is all that's left to finish this section, and that will be the topic of the next video. Thank you for watching. Our search screen is looking great, but still needs navigation to be complete. We've seen how to use both navigation path and navigation link to complete this. Out of the two, let's use navigation path for this screen. Navigation links are easier, but come with performance issues. If you're just joining us, the starter code for this video is in the description. Let's start in search view. Make a new line after search view model. At state private var navigation path equals navigation path. This variable will allow the view to track and control navigation history. Inside navigation stack, add parentheses, path, $, navigation path. This binds the stack's navigation state to our navigation path, letting us push and display views. Scrolling down, we need to append a title to our navigation path when it's clicked. One way is to add a tab gesture to our async image. Make a new line after .frame, .on tab gesture, navigation path, .append title. We just need to tell the path where to go when there's a title object. Scrolling further down, make a new line after .task, .navigation destination or destination. In for, type title.self, tab, press enter to complete the closure. The closure variable can be title, inside the braces, title detail view, title. When the title struct is passed into our navigation path, the view will navigate to title detail view, passing in the tab title. We're ready to run. Please update your API keys for the movie database and the YouTube API inside api-config.json. Press Command R to run. Our app is running. Navigate to search. Click on the title. Perfect. Our title detail screen is working. This completes the search screen. To wrap up, I would like to add a button to the title detail screen for the final section. Open title detail view. Make some room after title overview. Button with braces. Label. Inside label text. Constants.downloadString.ghost button. We'll just keep the same button style already made earlier. I do want the button to be in the middle of the screen. Before the button, type hstack with braces. Put 2 spacers. Cut the button and paste it in between. This will center the button. Press Command R to run. The app is running. Click on any title. And our button is showing correctly. This completes our async search bar. We've come a long way with this app, and I want to thank you all for the support throughout this journey. I'll see you in the final section, SwiftData. SwiftData is Apple's modern framework for managing data offline. It's efficient, lightweight, and easy to use. In our app so far, we display data primarily from the Movie Database API. The goal in this section is to save and delete titles in the Download tab. If you're just joining us, the starting code is in the description, so you can code along. The first step in this journey is to get our title model, SwiftData, ready. Starting in title.swift, we can replace import foundation with SwiftData. Foundation wasn't used in this file, and the SwiftData import allows us access to the library. The title struct is what will be saved in our data, therefore, it needs to be marked with @model. To properly use this macro, change struct to class. @model converts a Swift class into a stored model that's managed by SwiftData. There are a few errors that happen with this change. The first of which is because init isn't used. Make some room after the poster path property, type init, and press enter to autocomplete. Adding init tells SwiftData exactly how to create our class from scratch. Without it, SwiftData can't properly initialize all stored properties when loading the model from storage. The next error is because our model isn't conforming to the decodable protocol. Scroll down, add a couple of new lines after init, required init, wait a few seconds, and autocomplete if it adds a decoder. Required init tells SwiftData how to create our model from the decoded JSON data. Since we also changed the struct to a class, required init makes sure any subclass can be decoded the same way. Before we complete the required init function, coding keys are needed to properly match the JSON's object property to ours. Right above required init, make some space, enum, coding keys, coding key with braces. Inside coding keys, case ID, case title, case name, case overview, case poster path. Inside required init, let container equals try decoder dot container keyed by coding keys dot self. This line creates a container that lets us access the JSON data using the keys defined in coding keys. Now that we have our container, we can try to decode and initialize our properties. ID equals try container dot decode if present int dot self for key dot ID. All our properties are optionals because there might be a chance the server data returns nil. In this case, I found decode if present is a safe way to continue. We just need to complete this for the rest of our properties. Title equals try container dot decode if present string dot self for key dot title. Copy this line and paste it 3 times. 1, 2, 3. Replace the rest of the properties. Name dot name, overview dot overview, and poster path dot poster path. Our model is SwiftData ready. The final step is to add a model container to our app. Open Blossom Movie app.swift. At the top, import SwiftData. After the window group closing brace, dot model container for title.self. This creates a SwiftData container that knows how to store and manage title objects. It'll handle saving, loading, and keeping our model data in sync with the database. With this, our model is ready. We'll put it to use in the next one. Thank you for watching. Saving and displaying data is a critical step for any app managing data. Lucky for us iOS developers, SwiftData makes these actions very simple. We'll showcase this in today's video. There are two places we can save titles in the app. The first is the download button in our home tab. That's a good place to start. Open home view. Make a new line after title detail path. Type @environment, parentheses, / model context, var, model context. This grabs our connection to SwiftData. With it, we can insert, delete, and save data anywhere in this view. Scroll down to our download button. Inside the braces, add model context .insert view model .hero title try ? Model context .save. Here we insert the hero title into SwiftData and then try to save it. Adding some kind of feedback would be a good idea, but this works for now. The second place we save is inside our title detail view. Let's navigate there. Make a new line after view model, @environment, / .model context, var, model context. Before we write the save logic, it's important to think about how our API data is structured. The movie database API has both movies and TV shows. For movies, it uses the property title. As for TV shows, it uses the property name. That's why we include the title name computer property in this view. It checks which property isn't nil and returns it. With this in mind, we shouldn't save the title to our database as is. This can result in a database where the name can be in two places. When we try to sort, a nightmare can occur. A simple solution is to modify the data before saving it. Scroll down to the download button. Inside the braces, type let save title equals title, save title .title equals title name, model context .insert save title, try ? Model context .save. By putting the title name in title, we make sure the title is in one place. It's odd to see that let was used instead of var here. Remember that title is now a class, not a struct. Let only locks the reference, but the properties inside are still mutable. Therefore, let is okay here. It's worth mentioning that this wasn't needed in the hero title save. That's because hero title will only show different movies. As we discussed, movies already have their name in title. The save feature is complete. Before testing, we need to display the data saved. Let's make the last file of this project with Command N, SwiftUI view, next, download view, create. After import SwiftUI, add import SwiftData, make some space before the body, @query var saved titles : bracket title. This line tells SwiftData to fetch all the saved titles. It also updates the list automatically whenever the database changes. Inside the body, we can delete hello world, add a navigation stack, then a quick logic check. If save titles that is empty, text no downloads .padding .font .title3 .bold. It's a good idea to display some kind of message if the list is empty. That way, the user doesn't just see an empty screen. Add an else after the if statement. We'll reuse our vertical list view to display the saved titles. One more thing before we test, open content view. Replace download string with download view. Please update both your API keys for the movie database and the YouTube APIs In API config.json, press Command R to run. Our app is up and running. Navigate to download. The empty list message is showing correctly. Go back to the Home tab. Press download on the hero title. Back to download. And our title is showing. Because we reused the vertical list view, navigation is already included. Let's go back home and select the trending movie. Download that one. Back to download. All good. Everything is working so far. There are a few things left to do, like being able to delete, not allowing duplicates, and sorting. We'll tackle all that in the next video. Thank you for watching. Deleting data is just as important as saving in any app. Users will most likely have data that they'll want to delete at some point. SwiftData makes this action insanely easy. In this video, we'll demonstrate how we can accomplish deleting as well as sorting in SwiftData. I would like to keep things Apple native and have the delete button as a list swipe action. Let's open a vertical list view to get started. We have to remember that this view is used for both our download list and upcoming movies list. This is important because we don't want to allow the swipe action in the upcoming list. To help keep things separated, we can add another property. Make a new line after titles, let can delete full. When this view is called, we can set can delete to true or false, helping us with our logic. We also need the model context to make changes to our database at environment, parentheses, / dot model context, var model context. Before moving on, scroll down to fix the error. Set the preview boolean to true. Scrolling back up, after the label closing brace, add dot swipe actions. Select the one with edge and content. Dot swipe actions allows us to define an edge, either leading or trailing. Leading will show at the front of the items, trailing at the end. For this action, go ahead and put dot trailing, tab over, and hit enter. I'll scroll down a bit. Inside our code block, we can first check if deleting is allowed. If can delete with braces. Inside here, make a button with a label. Our label will be image system name with quotes. Inside the quotes, hit Command-Shift-L, look up trash, choose the first one, add a tint modifier. Let's make it red. So far so good. Inside the button logic, we need to delete the title, model context, dot delete, title, try, question mark, model context, dot save. This completes our swiping logic. There are a few errors to address before testing. Open upcoming view, click on the error, fix, false. Lastly, go to download view, click on the error, true. Please update your API keys inside API config.json, hit Command R to run. Our simulator is up, click on download, swipe the first title. It looks like I accidentally put the swipe action on leading. Easy fix. Go to a vertical list view. There it is. Switch it to trailing. Rerun the app. We're back. My apologies. Let's go to download. Swipe to delete the first item. Close the app. Reopen. Back to download. Looks good. We do need to check our upcoming tab. Try to swipe. Nice. We're not able to. Just a couple of more things left. I would like no duplicate titles in our data. That's an easy change. Open title.swift. Before var ID, type attribute dot unique. This macro makes sure that each title saved in SwiftData has a unique ID. Therefore, if two titles have the same ID, saving won't be allowed, preventing duplicates. I would also like to sort the list in alphabetical order. For this, open download view, add a parenthesis after query, sort :title.title. This macro will sort our SwiftData titles alphabetically by the title property. Remember, when we save our titles, we make sure all names go into the title property. Let's run this code and test it. Our simulator is up. Try to save the hero title a few times. Go to download, and it only saved once. In home, download a few titles so we can test the sorting. Get some TV shows. One more TV show. Back to download. Looks like it's in working order. We're all set with these features. There is a small bug left in the app. We'll tackle it in the next one. Thank you for watching. Bugs are a natural part of development. Where there's code, bugs can and will appear. We combat this by testing our apps and trying to catch bugs before production. At this stage, our app has all the features we wanted to add. However, if we go to the upcoming tab, click on the first title, download, the screen goes white. It's important to note, this bug only happens on the upcoming and download tab. The common denominator of these tabs is that they were made with navigation links instead of navigation paths. Another reason not to use navigation links in production. The best solution is to rewire our upcoming and download tabs to use paths. We have seen this a few times in the course already. I challenge you to do this on your own and test your skills. Use search view as a guide. For our purposes, when the download button is pressed, we'll dismiss the detail screen. This is definitely a workaround to show different options, but using navigation paths is a true solution. To start, open title detail view, make some space before the title property, at environment, open parentheses, \dismiss, var dismiss. This property provides access to the current view's dismiss action. We can call dismiss to close a sheet or navigation destination when needed. We'll place this in our download button after everything saves. Scroll down. After model context.save, dismiss. Please update your API keys in API config.json. Press Command R to run. Our simulator is up and running. Go to upcoming. Click on the second title. Download. Nice. No more white screen. To finish off the iOS 18 version of this app, I want to display errors better. Please remove the API keys and rerun the app. The simulator is up, and as you can see, the home screen error is real sloppy. Going into the search tab, it looks much better. Let's have all our errors look like this. Inside Xcode, open search view, copy the modifiers on our error text. Open constants, scroll down, paste the modifiers at the end for now, copy and paste the ghost button extension, rename the second one error message, Get the modifiers and paste them inside error message. With our new extension, we can go to Home View, scroll down to our error case, delete everything inside text, type error.localize description, and add the .error message modifier. I would like this error to be at the center of the screen. We used our geometry reader for the progress view last time. Scroll up to the progress case, copy the frame modifier, scroll back down, paste it after the error message modifier. Before moving on, copy both modifiers, open title detail view, paste the modifiers on the error, replace geo with geometry, we just need upcoming view, same thing with the modifiers. That should be good. Please run the project. The errors look so much better. That completes the iOS 18 version of this app and the course. I want to thank you all for the support. We're going to take a break from YouTube and work on our first paid course. It's going to only use SwiftData and SwiftUI to keep things lean and fast. Thank you again, and I'll see you in the next one.